attacks have become a genuine problem worldwide. Malware attacks are considered as a casus belli for some countries. And the antivirus software market is estimated to reach around $7.16 billion until 2030. So all of this means that malware is quite malware detection. In fact, is quite an important topic in the software environment. Okay, so this being said, that malware is important and should be treated carefully. This project intends to present another way, another method of detecting software in real time. This method is based on a new Intel feature called Intel Processor Trace. It has real-time streaming. It is a real-time streaming platform for behavioral data analysis, and it uses a decoupled architecture for data transfer in order to accommodate multiple users. Okay, so a bit of technical background. A little bit about how the processor executes code, and more importantly, how we define software behavior. Software is a set of instructions, and code flow or behavior, as we call it in this paper, is the order in which these instructions are executed. At the technical level, each processor has a register called instruction pointer that points to the next instruction that needs to be executed by the said processor. There are two types of instructions that modify the instruction pointer. These are direct transfer, power transfer, and indirect transfer. Execution. Okay. Transfer of execution. The direct transfer are near relative jumps. If you've written code in assembly, you might have encountered the Junuku instructions that are modifying the instruction pointer relative to its current content. So you either decrease it or increase it by a certain amount. These are direct transfer. There are also indirect transfer instructions that modify the instruction pointer register completely. These are jumps which have the memory address specified, calls, and read. They take the instruction from the stack and place it in the instruction pointer. Also, there are far transfer instructions. These are interrupts, system calls, and exceptions. These are most commonly used when calling a system function, something like printf or I don't know, create file, something like that. The execution performs a syscall that enters in the kernel. Okay. So, talking about Intel Processor Trace, what is it and what it does. So, Intel Processor Trace is a change of flow instruction tracing with low latency. Change of flow instructions are what I've just explained, are instructions that modify the instruction pointer, and in terms modifying the flow of the code. It delivers information about this these instructions, if they were executed, what address was the instruction pointer modified to. For example, as I said, you might have call instructions that are that have a memory operand. These operands, these values could change dynamically based on the value in memory, and you cannot tell at compile time where will the code jump. This is important because malware often changes those values. For example, as a result of a buffer overflow, might overwrite such addresses, and even though the user might think the application runs, it's a normal application. In fact, it could do malicious stuff inside. Okay. Interprocessor trace delivers information in packet, in bytes, that have to be decoded in order to determine what has happened during the execution of the code. It also has, it is configurable. The output is configurable. The way those packets are stored in memory, they can either be stored in a continuous buffer or in multiple intermittent buffers. This mechanism also allows for interrupts to be triggered when a certain amount of bytes have been produced. These interrupts can be then captured, and a mechanism could replace the full buffer with a new one, and in turn send it to a processing system. Okay, besides this, interprocessor trace also offers some metadata packets such as timestamps. So the packet decoding could be pinpointed in time, and as such you can have a real-time overview of the execution. Okay, so a few examples of packets. These are taken, not taken packets. They describe direct transfer instructions. These were relative to the current instruction pointers, such as jump 0, jump 0, stuff like that. And they describe, there's 1 byte for each jump instruction. They describe if said instruction was executed, so the instruction pointer did modify or didn't modify. So there's 1 in case the ID changed, 0 if it didn't. Another type of packet, these are target instruction pointer packets. These specify the address at which far jump redirected the instruction pointer or an interrupt or stuff like that. Okay, so why is this important? Well, as I said, change of flow and in terms change of instruction pointer describe the behavior of an application. And the question of this paper was, could this technology be used in a real-time manner to detect malware based solely on the behavior of the application? In order to do this, to make a real-time application for tracing, I've used a producer-consumer architecture. There's the client side that runs on the client machine, where a driver is installed and the user application. The driver sets the interprocessor trace mechanism, and sends to the user application buffers of data that were traced by the interprocessor trace. In order to communicate with the server, so the analysis of the trace is done on a server, on a centralized point. Apache Kafka is used, so what comes from the driver is then packed and sent to Apache Kafka, where is then decoded by the analysis server, and the trace is decoded, and the behavior of the application, the traced application, is analyzed.
I think, Christy, it's better to spend only 10 minutes for presentation and to keep 5 minutes for discussion. So you have 1 more minute for your presentation.
Okay, so here I just describe in detail what is happening. So an experiment has been done to prove that the interprocessor trace could in fact determine malicious behavior in an application. Buffer overflow vulnerability was exploited, and the trace looked like this. It's the same in the two pictures. We can see the behavior of the same application. The rightmost picture presents the benign execution, and the leftmost presents the malicious execution. It can be seen that there are distinctive patterns for at the moment in which the malware was executed, the exploit executed, and based on this, we can deduce that interprocessor trace could in fact be used as a real-time behavioral analysis. Another interesting thing, we can see that the red dots are the malicious addresses, the addresses that the process jumped to when it was exploited. It can be seen that the benign pattern, which is the blue one, does not match with the red one, which is the exploited one. So this could be also a factor of determining if the execution is malicious or not. A performance test was done in order to determine the slowdown of the system while an application was traced, or the entire user space, all the applications that were running on a system were traced, and to see the slowdown. So there is, of course, a slowdown, but it's not that critical. It's 8.56% for the entire user space tracing. So, this is good news. Okay, future work. It was intended, machine learning engine was intended to be coupled to the received data from the driver, in order to perform automatic learning on malicious traces. I didn't have time to complete that, but now it's future work. And in conclusion, besides what I presented, interprocessor trace is currently being used by CrowdStrike to in one of their products to analyze malware at runtime, not with the same technique as I presented. They use a bit of a different technique, but it shows that interprocessor trace has capabilities to be used.
Okay, thank you very much for your nice presentation. Maybe there are questions from the audience. Okay, if not, please.
Yeah, so one first question. Could you go back please to the architecture?
Sure. Sorry. Okay. Okay.
You've mentioned there that there's a latency using this Apache Kafka. Can you mention how low or how low the latency is?
Well, it is enough to make it not perfectly real time, to make the system not perfectly real time, but is not big enough to make it unusable. So I haven't measured the performance of Apache.
And do you have an intuition? Can you appreciate just?
Well, no. I'm sorry, but.
And the second question, is this solution that you proposed applicable to some edge computing solutions? For instance, do you know about neural compute stick from Intel? Would it be possible to use it for a kind of device that you plug it in a USB?
You can trace the entire system, you can trace the kernel node. If you plug in a USB device into a computer that has Intel processor trace, you can specify the Intel processor trace to trace the kernel node and especially the driver that handles data from and to the USB stick. So yes, you can use it to detect malware on a central basis.
Thank you.
How much trust do I put in that your system does the job? Do you have some performance metrics or
Yes,
are you sure that it detects all the malicious part?
No, this is just a proof of concept that it can be used, and you can see patterns in the malicious execution. But
I see 3 patterns there. Is it correct?
I'm sorry.
I see 3 patterns there.
Yes, there are 3 patterns for
the second picture.
Addresses. The second picture is the benign one, so it shouldn't be this is just the baseline, the right one. The left one is the attack patterns. At the moment, the scope of this paper and this thesis was not to produce an efficient way to trace an application to perform detection. It was just a proof that.
Okay, and one pattern is that. Which is the pattern that you use?
Okay, so there are 3 patterns. It can be. You can discover many more patterns. These are just the easiest one. The most obvious one is the address use. The exploit was a buffer overflow, meaning that the address is that the hacker, the attacker modified should not match the benign ones, and this is just what we see. These red dots here do not have a benign counterpart. So this is just one metric that looking at interprocessor trace could use. For example, the yellow pattern is the flow update packets. These are packets that are being emitted when an interrupt is performed. As I said, system calls do interrupts, so that the user application enters the kernel.
Okay.
This might be
Thank you very much for your presentation and your answers. So we used to congratulate the presenter. I invite the next one. I assume to the rescue Alexander Natalia.
Oh, hello, my name is Alexandra. And today I will present my geometry-based solution for 3D facial expression synthesis. So, first of all, what is exactly facial expression synthesis? I'm going to start with a practical example. Let's take a live simulation game in which we can have avatars that have different expressions based on their moods. But what if I could have an avatar that is of an image of my face. So it's a 3D model that looks like my face and can have different expressions, and I can use it in animations or games. This is the question I am going to try to answer today. So first of all, a brief overview of related work. I took here 2 papers. In the paper on the right, you can see they generated the models based on images which already have different expressions, and then they have a solution for morphing them, but here it's important to know that they need images of facial expressions. And the other method is learning-based. It needs training data to infer the expression, learns some coefficients, and applies them to the model to create an expression model. In both these cases, we need more than just a simple image of the neutral expression. And in my solution, I just need an image of the neutral expression of a person, which I can use to create the model and modify the expression subsequently. So this is the framework that I used first of all for 3D model generation. It's based on the 2 papers that I quoted there. So first of all, it's a model fitting framework in which basically we have a generic 3D model with tens of thousands of vertices, on which, and also an input image of the face. We use a landmark detector on both of them, and the landmarks are important points on the face, and I receive them in the form of 3D coordinates in the space. And I map them. What is new here compared to the paper written below is that I use the face mesh from MediaPipe, in which I get 468 landmarks. Before there were only 73, so this is more accurate. Now, what exactly did I use to modify this? It's important to say that basically we use interpolation for obtaining the vertices except for these landmarks, and so if I change the positions of landmark, let's say for instance if I change the z index of the nose and then I interpolate, I'm basically going to get an elongated nose. This is a simplified example. So basically I want to use facts, which you can see here, it's a little spoiler, AU1. What is AU? They are action units, which are part of the facial action coding system developed by Ekman, a psychologist who did research in which he basically tried to split expressions into micro-expressions. What does that mean? Basically, when I smile, you can see both my eyes and my mouth have some expressions, but they are not dependent on each other, and they can be splitted. So basically, he split them into the smallest independent expressions. And I looked into the action units for eyebrows first, because eyebrows are important in at least 4 out of 7 universal expressions. And geometrically, what did I do is I simplified the eyebrow to be viewed as this polygon with the inner, upper, inner, lower, corner, upper, corner, lower, and exterior, which are denoted correspondingly on this image. And for inner brow raiser, I basically need to take the inner part of the brow and raise it like this. And how I did this, I basically took, you can see CL, PCL on the graphic. It's the parallel to the inner segment of the brow, and on it I find point O. If I have a point A that I want to modify, it's a point on my initial eyebrow, and I take point O on this CL, PCL such that OA is also parallel to the upper limit, and then I rotate it by a given parameter theta. I'm not going to get right now into the mathematical formulas, they're written in the paper, but at this point it's fully the transformation is fully constrained, and it also can be used for brow lowerer. I just need to change the sign of theta, and the inner brow is going to go down instead of upwards. Another action unit for the brow is the outer brow raiser, which is a look we probably get from our parents when we got home too late. And I also use the same view of the eyebrow, the same points. With blue you can see the original eyebrow, and with red is how I want to raise it. So what I need to do for this is basically I take on the direction CU, CL, I take CU prime by an offset, which I can change, so it's customizable. And then I also need to take CL prime, which I take such that the angle between the upper and the lower segment of the brow stays the same. As you can see, is the same alpha. And then the other 3 points stay the same, E, IU, and IL. And for a point on the original boundary of the eyebrow, for a point P, how do I get point P prime? I just intersect AP with the corresponding segment. For instance, for IU-CU, I'm going to have the corresponding segment IU-CU prime in the transformed eyebrow, and P prime is the intersection of AP with this segment. It also works for if the intersection here is inwards, but it works if it's outwards too. I have more cases covered in my paper, but they're analogous, and this is probably the most used one in practice. By now I covered some expressions for the eyebrows, which are very specific to them, but I also identified that we have some parts of the face that can be grouped because they look similarly. For instance, the eyes and the lips, as well as the muscles corresponding to them. I call them concentric, although they are not really round or circular, but they have this sort of elliptic shape. And I realized we can just use the classic resize in which we expand or shrink on all dimensions, because for instance, when I open my eyes, they open on the vertical size, but they stay the same on the horizontal size, the same on the horizontal axis is the same size. So what I did was take the horizontal axis of the part, and for each point I take the perpendicular from that point to the axis. Basically I obtain a vector that can be multiplied by a scalar. If it's larger than 1, I'm going to have an expansion. If it's lower than 1, a compression. Again here, blue is the original one and red is the transformed one. And now for the results that I've talked about, and this is what the results look like. On the first row we have first the reference neutral model, and then on the first row from right to left, the inner brow razor, the outer brow razor, and the brow lowerer, and below we have on the first 2 images the vertical contraction applied on the muscles corresponding to the eyes. Then in the third picture also vertical compression on the lips, and in the last one it's a vertical expansion on the lips. It's not exactly an action unit, but it's some sort of, I call it a lip plumping effect. So this indicates that we can use this framework for simulating some sort of aesthetic surgeries as well. So also, how did I evaluate this method? I gave this data into a survey to 91 people, but they didn't know the action units for each model before, and I asked them to map to each model the action unit they thought was corresponding to it, except for model 7, which was an open answer in which I asked them to say what effect they noticed. And these are the results that were obtained. We can see we have over 90% for 3 of the models, and I also want to say for model 4 we see 33, 34, 11, 18, but I considered if we look here from 42 to 45, these are very similar. There are some sort of variations of closed eyes, so if we consider they are all okay and we add them up, we also get over 90% for this. We also have 70% for action unit 1, and a total of about 76% for model 6, in which they noticed a lip augmentation effect or an action unit that was connected to the lip change. The poorest results indeed were obtained on action unit 4, And I analyzed this, and I realized it was not the most user-friendly survey, in the sense that they didn't see them all after the other. They had to keep scrolling up and down because there was only one model at the point, and if they wanted to see the reference model, they needed to scroll. And indeed, if we look at the model 1 for action unit 4, and we don't see the reference model, we can't tell for sure if the inner brow is lowered or the outer brow is raised. And I think we would have gotten even better results if I had made a more friendly user survey. So, in conclusion, we obtained a customizable framework. As we have modifiable parameters, we can obtain more subtle or more exaggerated expressions which are used in animation to clearly convey the emotions of characters. It's effective, as we got over 90% correctly identified expressions in 4 out of 7 cases. And as I mentioned before, this can be used in 3D animation or for creation of 3D avatars. As for future work, I could expand to more muscles by using already defined geometrical transformations, or even expand the geometry library itself with new operations that I find to be common for some muscles. Thank you for your attention, and if you have any questions, I'd be glad to answer.
Okay. Are there any questions on your side? Do you have any?
Thank you for your presentation, very interesting. It's amazing that you managed to obtain 91 answers. Now
I was also surprised.
It's a good evaluation. How did you resist the temptation to use machine learning and you have this nice and classical approach?
It was an experiment to see if I can actually use, let's say, classical geometry in this area that, as you said, is very often approached from a machine learning, deep learning approach. It's also probably a personal passion I had for geometry since school, and I wanted to see how I can apply this to obtaining expressions, and I took the action units and I tried to simplify them and translate them into the mathematical space and see how I can obtain these transformations.
And it seems that it works. Without machine learning, so we do not need machine learning everywhere.
I think it's good to have, this has its, I think each approach has its advantages and drawbacks. As I said, for this we don't need any data except for the generic 3D model and an input, a single input image of the face with a neutral expression. So we don't need any other data.
Okay, thank you.
I have 3 questions for you. One is, I think, quite simple. Have you tried to change from one model to the other, like facial model, facial expression? And if yes, what is the time needed to do the transformation?
So how much time it takes to? I don't think I think it does take indeed about 10 seconds, I believe. This is also because I usually need to run it twice, because the texture on the models is also obtained from the input image, so the colors, and I need to run it first on the neutral model, then I need to find the new landmarks for the expressions. I need to run it again, and I need to use the initial colors and the new landmarks, because otherwise I would have all the initial colors mapped. For instance, I would raise my eyebrow, but the color would still be in the initial place. So basically it takes so long because I need to run it twice. So indeed it's probably not that effective time-wise, and it's another place for improvement.
You've mentioned about the action units, and you've showed us a brief collection of them where you tried to show us that it works fine. Are there other action units that would be maybe more difficult to model, and that might be correlated with what you said about more muscles to
yes, for instance, these transformations that I took, they work with just 2D transformations as you saw, but other transformations would involve changing the Z-index as well. For instance, for the cheek razor, I did a mapping of all muscles, but I used only a few of them, as you could see, but I have the mapping between those 468 landmarks and the muscles, and I think from there we could also study some 3D modifications.
And the last question, you've mentioned about the 91 people, and that was indeed impressive. Can you explain us how you've made the choice for, I mean, are there people that do know about facial expressions? Are there psychologists or are no people?
Yes, so I also have this data with the backgrounds of the people that answered in the paper. Most of them were in the computer science domain because those were most reachable by me. I also had some important percentage in who were in the medical field, either students or professionals, and I believe this was sort of relevant since they might also know about this. But anyway, about 70% of people said they hadn't heard about facts before this survey. So I tried to explain it very briefly in the survey such that they could understand and make informed decisions. Probably I would have obtained other results if it had been directed to people who were familiar with this system.
Just a brief comment at the end, because I think the question is out of our frame. Maybe you could also try with software that already reads facial expressions, for instance, Face Reader, or something similar, which is quite obvious you didn't do in this case. But in
yes.
the future work, that could be an idea. Maybe even to compare with, between them. Okay, thank you very much.
Thank you.
Congratulations for your work. The next topic is about music and emotion recognition in music.
Okay. Hello, my name is Tanya Mihanka, and today I will present you the paper that I have prepared for this conference, Film Music, a music emotional interpretation application using WinKNN. This is the structure of my today's presentation. First of all, I will talk about the objectives and motivation of the paper, a few related works in this domain, my proposed solution, and a few conclusions at the end. The objectives that I had in mind when I implemented this application include the fact that I wanted to provide a new, more unconventional way for filtering music through emotions. And I thought that music means nothing if it cannot be listened to, so I also wanted to include song listenings and also displaying other aspects related to the songs. And moreover, I wanted to incorporate music emotion recognition in order to allow users to find out what emotions a certain song expresses. And I wanted my application to be usable on both desktop and mobile because we want to listen to music everywhere. What motivated me to implement this app? First of all, the fact that music is everywhere and we nowadays listen to it even unconsciously. Then the love for music. I personally love listening to music, and I strongly believe that there is a great correlation between music and emotions, and music expresses emotions. Then I think we need a music emotion-oriented application because nowadays there are a lot of apps that filter music by the name of the artist or album. But however, this already existing application may not meet the increasing demand of easy and effective information access because the diversity of music tends to be quite overwhelming for users. And last but not least, the interest in exploring machine learning in the domain of interest, such as music. I will mention a lot in my presentation James Russell's complex model of emotion. This is a dimensional approach of emotion conceptualization that represents emotions as points in a two-dimensional quadrant. On the x-axis we have the balance values, and on the y-axis the arousal values. The first related work is a research made by Music's Match AI team. What is particular about this paper is the fact that they classified lyrical and audio features separately, but in a synchronized fashion. They use a synchronized lyrics emotion data set, and for the lyrical classification they use deep neural network models, and for the audio ones, convolutional neural networks. The next one is DJ Running, an emotion-based recommendation system for runners. What is nice about this app is the fact that it provides a personalized music experience. James Russell two-dimensional emotion model was used. Spotify API was used in order to retrieve the songs of interest, and the nearest neighbor search algorithm was implemented for recommendation. And the last one is a paper that describes emotion analysis based on lyrical and audio features that are classified together in this case. Also a two-dimensional emotion model used, Last.fm website used for creating a training data set, and K nearest neighbor implemented for classification. And now my proposed solution. To create my data set, I used Last.fm API as it provides songs that are tagged by users, so it maps perfectly to our need. I chose a set of 8 emotion classes that cover the wide range of emotions, and these are afraid, angry, bored, calm, excited, happy, romantic, and sad. And for each of them, I searched for representative tags by studying different emotion models, such as James Russell's Circumflex model and Plotkin's Wheel of Emotions. And with the help of the API, I retrieved the songs that were tagged by those particular tags. I consider both lyrical and audio features when creating the dataset, because I consider that both make the song as a whole. Also, to complete the dataset, I retrieved the lyrics of the songs and some features that I will mention later. To retrieve the lyrics, I used 2 options, an API, and the other is by parsing the HTML page of a music site, Absolute Lyrics. And I have a total of 538 songs in the database. And this is how the items in the database look like. I have the emotion class that has a name and some particular text, and also the song that has a name, artist, an array of lyrics, the associated emotion classes, and a few features. The lyrical features, they were retrieved by using segmentation of lyrics. A 3-dimensional model was used in this case based on paired emotional state that represents an extension of James Russell's Circumflex model. So I had to copy 3 values, balance, arousal, and dominance. Balance represents the positive or negative nature of song, arousal is stimulation, and dominance the controlling nature of the song. And these values were retrieved for the entire song by performing an arithmetic mean of the individual values of each word. And these were taken from the effective norms of English words dictionary that has these values for a set of words. However, this set is quite limited in the number of words it has, so I also try to enrich it using synonyms by those words. These were retrieved by using the Java wordnet library, and in order to make sure that they are as accurate as possible for the words, I also perform part of speech tagging on the lyrics by using the OpenNLP library from Apache. Okay, about the audio features, Spotify API was used to retrieve them. These features include tempo, energy, mode, loudness, and visibility. And I also perform normalization on all the features because they range in different intervals, and I normalize them to be in the interval 0, 1. And this is the formula I used for normalization. It's a min-max scaling normalization. About the classification, I use the weighted k-nearest neighbor because the problem of the classical KNN is the fact that it takes the majority vote and it doesn't consider the distance between the points. But the weighted KNN solves this by assigning weight to the points, so the points that are closer to the classification points receive higher weights while the others less weights. And the Euclidean distance was used as a similarity function. And I also apply feature weighting because I thought that not all features should be equally considered when classifying, because some of them may be more relevant for expressing emotions. And these are the weights I used for the features. And while doing my research for this paper, I often came across the fact that just a few of the papers actually revealed the accuracy of their algorithm due to the subjectivity of emotions. When I wanted to validate myself, I made a survey in which 27 participants took part. There was a set of 10 songs from I thought that expressed different emotions. I tried to diversify it. And I had to choose between weak, medium, and strong, or how strong I feel each of the 8 emotion classes our algorithm supports. And after analyzing the results, I obtained an accuracy of 60%. And how I complete this accuracy, given the result of the form, I try to compute the percentage each emotion has for each song by assigning some weights to those options. For weak I assigned weight 0, for strong 100, and for medium 50. I computed the sum of all these weights and divided by the total number of classifications. In order to compute the total accuracy, I relied on the top 3 motions because I strongly believe that we cannot say that a song is classified into only one emotion because, well, it may be calm and romantic at the same time. So this is why I took the top 3 motions. I counted how many of them matched and divided by the maximum number of possibilities and obtained this accuracy of 60%. And some results. In the left part we can see a song that was correctly classified by the classifier because all 3 emotions match regardless of their order, and in the right side we can see that only 2 out of 3 emotions match. And a few conclusions. What we achieved by implementing this app is the fact that we provided a more complex way for cataloging music, emotions. We consider both lyrical and audio features because they both make the song as a whole. We provided not only the ability to filter songs, but also to classify new songs, so it is a more elaborated app. We used the 3-dimensional emotion model, unlike the majority of the papers that use only a 2-dimensional model, and it's also a cross-platform app that is quite simple and intuitive to use. A few limitations. First of all, it was the subjectivity of emotions that we managed to overcome by making that survey. It was quite hard to find the lyrics of the songs, unlike I previously thought. We have no certainty that the tags given by the API are actually accurate. I don't know if anyone validates them. And the context was not properly taken into consideration when processing the lyrics. And a few future improvements. First of all, I would like to create a training data set by ourselves by perhaps making a similar survey with the one we did for this paper, to offer more personalized music experience by taking into consideration also some personal aspects related to the users, to provide support for more languages, not only English, to better take into consideration the context, and why not to try other classification algorithms. And the bibliography, and thank you. And if there are any questions.
Thank you for your interesting presentation. Questions for audience, please? We can start with some questions. You mentioned danceability and energy of music. How do you compute these features? Danceability.
Well, they are retrieved by using the Spotify API, so it provides. Yes, they provide more features, but I only took the ones that I consider relevant for expressing emotions. And well, I consider that danceability, for example, is relevant because a song that is more danceable may express like a more happy, excited mood.
This is your assumption, but the machine learning algorithm confirms that assumption.
Yes, usually yes. The songs that are more danceable, are happy, excited, well, it's like more positive. And
did you make experiments on this line, or did you compute some feature importance, and based on that computation you realized that danceability is correlated with happiness?
Well, yes, and also given the results of that survey that I made, they match this assumption. They confirmed it.
You mentioned afraid, an emotion there, afraid.
Yes.
How can you give some examples how the software works on that kind of particular emotion? Do you have some music related to afraid?
Honestly, I don't know the songs that I have in my data set that were afraid, but it's like how the music sounds. It's more, because I consider both lyrical and audio. And this is why sometimes it was, for example, I had some songs that sound in a way, but the lyrics were somehow not correlated to the lyrics. So the audio and lyrics were not, in my opinion at least, they were not very correlated. So usually the sounds that sounded more afraid.
And you invented the accuracy metric, isn't it?
Yes.
It's your proposal.
Yes.
Okay, thank you.
I have one question and maybe some others, depending on your answer. So you've mentioned activation tables, okay? And also the fact that you've chosen 8 emotions that are this a vector of emotions. Are there in your model any correlation between the 2 models?
So the emotion classes and?
Yes, the activation valence plane, the one that you've mentioned also in, so the circumflex model, so to say, it's also the Russell's circumflex model. And also you said, and that is the third model actually, the 3D model of emotion. Can you make things a bit clearer for us?
So it's a 3D model because I considered those three values, valence that expresses the positive or negative nature of the song, arousal and dominance, as I said, and I chose those emotion classes in order to retrieve the songs, so to associate an emotion to each song in the data set. And the features were retrieved by the lyrics in order to so in the data set the emotion was taken from the 8 emotion classes and the features, and these were like correlated in order to classify new songs. So basically I relied on the features. So I computed the same features for a new song that were classified, and given the data set that I had, I tried to search the one that better matched the data set.
Can you develop a bit more about the context? You said at the end that that would be a possible future work.
Well, when I processed the lyrics, the context was not properly taken into consideration because, well, I tried to find negations, for example, in order to, well, they like kind of reversed the meaning of a sentence, for example, in the lyrics. But I would like to go like further to take more. I saw in the research that I made, for example, it was a sentence, "Kill the happy child," and well, they are quite opposite in kill and happy. And to go deeper and try to see the context and not only negations, but also these opposite words, for example, in a sentence.
As you might already know, and you said it, there are a lot of solutions for music and emotions, how to understand all this connection. Can you emphasize on the original approach of yours in this paper you presented?
Well, I also used the three-dimensional model, so more features were considered, not only the valence and arousal that were mostly considered by the majority of the paper, and also the fact that well, the application doesn't only classifies a new song, it provides also the to filter and well, in the application the user can choose his or her mood, and he will see only songs that match that mood, and also well, he has a personal collection of favorites, so also the UI part of the application that, well, I don't have time to show it here because of the limited time.
Thank you very much.
The next paper is a mysterious one. It's about sonar cube, technical debt. And even more is about extending technical debt.
Oh, good evening. Is it mysterious? I thought it was quite explicit, actually.
For me, it is mysterious.
It is mysterious. Okay.
How do you want to extend a technical debt?
You will see in a bit. I'm going to share the screen right away, but it's going to take me a while. Great. Okay, hello, my name is Dragoš, and today I'll be presenting to you the paper entitled Extending the Sonar Cube Technical Debt, Mysterious. I'm going to have you excuse me, by force of habit, I just attached the abstract here, you're free to read it, but long story short, you all know that quality maintenance is one of the most vital activities in the process of software engineering, and a lot more companies are investing a lot of money into providing the newest and the best software quality assessment tools. And what we noticed that for the specific metric of technical debt, not any of these software quality tools are not up to date with the newest quality standards for information technology. So what we want to target, what we aim for with this research is creating an extension for one of the more popular software quality assessment tools that will actually calculate the technical debt metric according to those quality standards that we just mentioned. A bit of theoretical introduction regarding the technical debt. It's a terminology that has been borrowed from the financial domain, and it is used more as a metaphor that will reflect just how hard it is to change continuously evolving software system based on the existing flaws and faulty implementations that are in a software product. For evaluation methods, we do have quite a few ones, but the most popular that is used nowadays is the scale methodology for estimating the technical debt. And if you think about it, it's just a summation of all the remediation costs for all the issues that are detected in the code. Now, as an implementation of the actual methodology, SonarQube, which is one of the most popular static code analysis tools, just implements this method. And we're going to see what are the shortcomings of the methodology that SonarQube uses for assessing the technical debt. If we go to the newest software quality standard for information technology, the ISO IEC 5055-2021, this one addresses the need for a better quantitative evaluation in terms of software quality. And for that purpose, it defines a series of measures, the automated source code quality measures for 4 software quality characteristics that were presented in a previous software quality standard. And these are the reliability, security, maintainability, and performance efficiency were separated as software quality characteristics, but for this purpose they were considered as just one. And for those 2 formulas that are shown there, the software quality defines a series of detection patterns for vulnerabilities that can be found in the code. And for every violation of a detection pattern score is calculated. And the summation of those detection pattern scores gives the score for a particular weakness that can be found in the code. And the score, actually summing more further those weakness scores that have been calculated, it will give the automated source quality, code quality measure for the software characteristic that that weakness corresponds to. How does that translate to the Sonar API? Currently, the SonarQube works on the same premise. It has a series of standard rules that, when violated, an issue will be generated with a level of severity and a remediation cost. And currently, the technical debt in SonarQube only considers those issues that are related only to the maintainability. So they are actually labeled as code smells, if you are more familiar with that term. And what we propose is to add a new metric to the SonarQube software, the extended technical debt, which would actually consider all the software quality characteristics that we mentioned in the previous slide. We would like to add the technical debt that is related to maintainability, the one that is related to the reliability, the one for security, and the one for performance and efficiency. SonarQube does not present issues that are strictly linked to the performance issues, but over the issues do have a performance tag. So if you were to calculate a separate technical debt for performance, it would be just redundant. So we would just have a supplementary amount. And for every software characteristic, maintainability, reliability, or security, we will just add the remediation effort for all the issues that are found that are linked to that software characteristic. What's interesting here, we do have already the technical debt for maintainability because it's the standard metric calculated by SonarQube. But for reliability and security, we do have a remediation effort that is also computed by SonarQube, but they are not quite complete because they are considering only the application, not the test packages. And also for the security technical debt, they are not considering the security hotspots, which are, in my honest opinion, a lot more grave than the vulnerabilities that they detect with the SonarCube normal analysis. So in order to add these new metrics, we created a custom plugin to be included in the SonarCube installation. And once the main flow of the analysis is run, aside from all the metrics that are calculated by SonarCube, we will also have all of those technical depths calculated for us. Okay? And as the research methodology, we opted for a longitudinal release-oriented approach because most of the times the technical depth suffers those spikes of increasing right before a new release, because a lot of people are pressured to deliver code untested and not really the best implementation they could make. And regarding data acquiring, we related to a technical depth data set that was specifically designed for this kind of research project. And it contains links to 31 projects of the Apache Software Foundation. And these are open source projects, and for these we just obtained the repositories for them and ran the analysis on all the releases for those respective projects. And I'm not going to get into any details about the automation. If you have any questions, you can go to it. But regarding the experimental results, we did run experiments for all the 31 projects, but we chose to present only 3 of them in the paper. These will be the most notable differences regarding the releases and the difference between the technical depth and our extended technical depth. And you can see firstly for the Zookeeper project, which would be the smallest out of them. It's a ratio increase of 16.5% in favor to the extended technical depth, so that would be a lot greater than what was initially estimated by SonarCube. The Cayenne application was a bit underwhelming because it didn't have such a great difference, which means that the remediation cost for bugs and for software security vulnerabilities was not that great, only of 11 extra days of development. But for Apache Hive, which is actually the biggest and the largest of the projects, and it has about, I think, 700,000 lines of code, you see that it's quite impressive in the first place that the technical depth was estimated to 627 days. But the extended technical depth, it adds up with 37 days of development, which for planning ahead of time quality maintenance activities really need to be aware of this amount of supplementary days and to know how to handle them, because it's not such a great ratio increase, but it should matter for the quality maintenance process. And here I wanted to show you just how the plugin looks like. I mean, what are the results of applying the plugin. If I can zoom in a little. Yep, I think a bit too much. This is a new tab that was added after the plugin was generated. And here you can see that we have the extended technical depth, the performance related depth. We also calculated the remediation effort for those issues that had the performance tag. Reliability technical depth and security technical depth. And you can see that they are also distributed by all the components of the source code. And if we show the history of this metric, you can see the evolution related to all the releases for this Apache Zookeeper project. And as a comparison to how it evolved related to the standard technical depth, yep, the darker line is the one corresponding for technical depth. You can see that they follow the same trend, but because the base technical depth is still the one for the maintainability issues for the cold smells that is calculated. But you can see that for a lot of the points on the graph, the extended technical depth just reaches greater heights than the technical depth, but is never lower than the one. Or not even, let's say, close, on a close difference. I think this is the lowest difference between the two of them, of only 3 days of extra development for solving the bugs and the vulnerability issues. Okay, going back, on this paper we believe that we presented the shortcomings of the current SonarCube technical depth estimation. We created this new SonarQube plugin, and it will be available in the not too far future. And we believe that new contribution for this software tool, which is so popular and so used in all the enterprises, is very relevant to the research community, and it represents a very good starting point for future refinements of this metric. And for future work, the Apache Software Foundation projects are mainly Java, not any other type of programming language. So we would like to find a new data set that would have more diverse projects in terms of programming languages, and even greater than 700,000 lines of code, because there are, and because but they are not so easy to find. And we may as well see just how our calculation relates to the standard one. Also considering the fact that for the Java language, there are the most rules defined by SonarQube, of over 600 or something, but for other programming languages it will be interesting to see, because there are a lot less. I think there are about 200 or 300 of rules, so not as many vulnerabilities or code smells to be found. That was the end of my presentation. Thank you for your time.
Very interesting presentation indeed. Questions if you have, please. If not, we can start with one question.
Yes, so you mentioned about the code smells. How did you use them, if you use them?
I'm sorry.
Code smells?
Yeah, regarding the code smells?
Yes.
What?
How did you use them in your proposing your solution?
No, they were already considered.
Okay.
That was the standard metric that was calculated by SonarQube. It already included all the remediation costs for all the code smells that were detected.
Another question, in relation with standard technical debt, can you estimate the cost cuts in developing apps when using your solution compared with the standard?
We should be able to, because I don't know, you mean, if you can repeat, do you mean the cost cuts in the development process?
Yes, I mean, yeah.
Yeah, well.
Yes.
Well, if it is used indeed, and if it is considered as a valid metric, well, I think that it would greatly influence the management of the manpower to be distributed for this quality maintenance activity, and to see just how costly it would be and how a lot. Yeah.
Okay, so it's kind of difficult for to estimate. Okay. Are there any risks or limitations of your tool that you can in practice?
Well, to be fair, this research has been conducted on a community edition SonarQube, of course, but it would be a lot more helpful if I had the possibility to include this continuous integration. I mean, to include it in a pipeline to have it run every time. Also, the analyses are very slow, and it would be really helpful if I would have had a number of workers to parallelize the process of analysis. So this would be the current limitations of my research.
I like that you mentioned that quality standard for software engineering. How much from that standard did you use? Did you have access to it?
Yeah, I did. It was open for access, and I just apart from the series of detection patterns that were mentioned, I covered, I think, all of the notions into this into my research and into this paper, all the notions that were mentioned there for defining those automated quality measures.
For instance, which measures?
For instance, they were exactly these measures for the 4 software quality.
Security,
exactly.
reliability, and
Yep.
And they provide guideline there how to.
Yeah, I mean, I couldn't follow them very the most faithfully, so to speak, because they are defining their own set of detection patterns. And SonarCube may or may not define all those detection patterns for the corresponding weaknesses. So if we were to be as close to the software quality standard as possible, we would have to identify those detection patterns that are not covered by SonarCube, and then we would have to add them again through a custom plugin into the SonarCube implementation, and then detect those violations, and only to make sure that it's the most complete possible.
Other questions, please? If not,
The next presenter is Tudor Malina, automatic detection of verbal deception in Romanian with artificial intelligence methods.
Hi, my name is Malina, and please raise your hand if you ever lied to someone. Okay. Please raise your hand if you told a lie or lied to someone in a context.
of course not.
Okay. My study is called Automatic Detection of Verbal Deception in Romanian with Artificial Intelligence Models, and I'm very glad that we have a lot of liars in this room. The purpose of this is to replace human expertise and get a better understanding of deceptive language. But you may ask why? Applications of this field are very vast, such as in business, jurisprudence, law enforcement, and national security.
And love.
Of course. Automatic deception detection merges fields of research such as sociology, interpersonal psychology, and computational models of deception detection. Unfortunately, relatively modest efforts, if any, have been made for the Romanian language, the spotlight being put on languages that are of interest, such as English, Italian, or Spanish. Moreover, a fundamental disadvantage is the one of creating a corpus of genuine deceptive language. For short related work, the main studies in this field can be divided into two groups: computationals, the ones created by computer science researchers, and non-computational, the ones by linguists or psychologists. Those are the researches I found to be the most important in each category. As for my research goals, I wanted to explore which language markers and indications are more successful to distinguish deception in Romanian. I decided to create a non-topic specific dataset with Romanian texts and to evaluate the effectiveness of a wide range of binary classifiers for predicting the truthfulness or deceptiveness of texts. For my representation, I used the LYWC, or Linguistic Inquiry and Word Count, which is a tool for textual examination where words are divided into psychologically relevant groups. The taxonomy of LYWC offers an effective technique for examining the emotional, cognitive, and structural components contained in language on a word-by-word basis. Words and word stems are classified in the LYWC internal lexicon along four broad dimensions: standard language processes, psychological processes, relativity, and personal concerns. The Romanian version of the lexicon incorporates a lot of entries, but only 73 categories related to psychological processes. From all the categories, we chose the most relevant classes. These categories would be self-reference terms, reference to others, negative emotion elements, motion words, belief-oriented vocabulary, words related to certainty, negation terms, sense terms, and positive emotion elements. Moreover, we added two more relevant values in the feature vector of each text. More specifically, the number of words represented in each text and the type-to-token ratio, or TTR. Inside the parentheses, you can see some examples that correspond to each category that we consider to be relevant in our study. As I mentioned, in our research goals, our dataset is a non-topic specific one, but there is another Romanian dataset that I want to introduce. Let's call it the best friend dataset. It covers 4 distinct cultures: US, India, Mexico, and Romania, and comprises of short, deceptive, and truthful statements on 3 different subjects of discussion: beliefs on abortion, views on capital punishment or death penalty, and sentiments about the best friend. We used only the ones related to best friend, as this topic is more suitable for this research to draw a comparison between data sets, the one created by us and the one created by them. On the right side of the slide, you can read an example of truth from this data set. Now let's talk about the Romiad dataset, Romanian, Minciuna, and Adevăr dataset that we created. We started with a Google form in order to obtain lies and truths on different autobiographical subjects. We then made a manual verification of the quality level of the text and a manual diacritics restoration. We normalized the text and we used LYWC to remove all the words that were not found in the linguistic inquiry and word count lexicon. These are 2 examples from the Romiad dataset where we bolded the text corresponding to words that are from the relevant categories that we chose from. For example, the word mă is a self-reference as it is a personal pronoun for the first person. To determine the difficulty of the classification task, we employed the Disney algorithm. It computes a nonlinear dimensionality reduction, which allows us to separate and visualize data that cannot be separated by a straight line. In the case of the Romiad dataset, the graphic resembles a blob in which elements from both classes are presented. Here, Disney cannot find structure, and the plot reflects the incapacity of distinguishing the 2 classes. Applying the same method to the best friend dataset, we created a semicircle shape, the graphic tending to differentiate the 2 classes at opposite poles of the figure. Now for the feature relevance, we used 2 methods, the Pearson correlation coefficient and relief algorithms. We computed the Pearson correlation coefficient between the features and the labels on the Romiad dataset. And unfortunately, all the values are close to 0, which means they are not really that relevant. On the other hand, on the best friend dataset, the values were between that range, and we can see an exponential increase in the values. This is the reason behind the quality of the classifiers trained on this dataset that we will talk about it a little bit later. For the relief algorithm, on the Romiad dataset, the features that were once found relevant by both the Pearson coefficient and the relief algorithm were words related to certainty, motion words, and the number of words. Much to our surprise, even though relief algorithm applied to our dataset scored mostly values above 0 when computing the values for the best friend dataset, all except 1 features received a negative score. Comparing these results with the ones obtained via Pearson coefficient, we can conclude that both algorithms found relevant 2 categories, inside language and sense-related terms. For the experimental approach, we use the sklearn library, and for testing and training, we ran several comparative experiments using 10-fold cross-validation on these algorithms for binary classification. Let's talk a little bit about the experimental results. First, we did an experiment with the full models, the 11 features that I presented. The values in the tables confirm that the classification task is solved more successfully in the case of the models trained on the best friend dataset, as it can be seen in all of the 3 tables. We then ran a second experiment with the simplified models with only the relevant features per dataset. The simplified model did not bring any major improvements in the results, even though we investigated the relevance of the features in the classification process. For the Romiad dataset, the accuracy improved for the classifiers based on decision tree and random forest. For the others classifiers, the values remained similar to the ones obtained with the full model. In contrast, for the best friend dataset, a deterioration in the quality of the classification task can be observed as for all the classifiers except the Gaussian naive-based one. The last, but not least, experiment we created was based on TF-IDF and the Bow model. There were 2 experiments that I concatenated in one. And another interesting conclusion that we draw is related to these models. Even though BAU and TF-IDF are considered to be simplistic models, they were able to achieve better results than the models trained with psychologically relevant categories. This made us conclude that a major part of the deceptive process, in the case of non-specific statements, is not related to which category of words we use, but which words we utilize. As a short comparison with SOTA, even though our study is considered to be a novelty from the point of view of experimented on Romanian dataset, we try to draw a comparison between the results that we obtained and the performance of other similar approaches, even though they are not implemented on a non-topic specific dataset or they are following different languages. As it can be deducted from the next table, we can observe that our approach has somewhat similar results to some of the approaches, but in some cases the difficulty of the task that we attended prevented us from attaining better results for our matrices. For our conclusions, the elements of novelty that we brought, such as the exploration of this natural language processing task in the Romanian language, the acquisition of truths and lies dataset, the Romiad one, and the analysis of it, were researched in this paper, all the research goals that we aim to accomplish being reached during our study. Although the classification algorithm provided good results, above the average in almost all of the experiments we performed, it is far from perfect and improvements can always be made. One improvement can be done in the data acquisition process by introducing a more rigorous acquisition process and more statements in the dataset. Also, more features can be added to the classification algorithm for an improvement in deception detection. For example, we can use word embeddings or even an automatic emotion analysis. Finally, another improvement that can be made is to the algorithms that we studied. Even though some of the results are favorable, a dive into some deep learning architectures would bring a new perspective on deception detection. For example, an architecture based on transformers might help with the difficulty of the classification task and bring better outcomes. Thank you.
Thank you for your interesting presentation. And we have time for questions, maybe from the audience.
I have a question. You mentioned that you removed, when creating the dataset, you removed words that were not in the lexicon you were working with.
The problem with this lexicon is that it's quite weird if you ask me. For example, we have the word pian, but we don't have chitară. But I cannot understand why. It's created by two researchers from Romania, and it's very difficult to, let's say, translate the lexicon from the English language to the Romanian one, because some of the words are just missing. I tried to, let's say, incorporate some of the words that I found. For example, I didn't find the word câine or pisică, so I tried to add those by comparing them with similar words. For example, căprioară, because it's also an animal. So that's why I removed them, because he was trying to look after them, but it was unnecessary at that point.
Yeah, I was curious how you can decide the words, but I didn't answer the question.
Just a funny thing about LYWC.
Any questions, please? You used two data sets,
Yes,
the best friend,
and one.
but there it's a lot of subjectivity there. Now, how can you distinguish between lying and or decepting and truth there?
In the best friend one,
Yes.
they considered for acquisition, for example, they took one person and said to them, please imagine your worst enemy, like your worst of them all, and imagine that you are best friends with them, so lie about that. And then after that, they put the person to tell a real story about a friend. So that's how they did the acquisition, and the differentiation was also based on LYWC. For example, it's considered that a person that lies uses more words, that's why I use the number of words in text, but a lower type token ratio because they tend to repeat themselves over and over again. So basically it's a feature vector that just counts psychologically relevant classes and does the comparison by that and the classification.
So the more you speak, the more you lie. This is one heuristic. And another one?
For example, it's considered that people that lie tend to use more sense terms because they try to create this evocative story. For example, I'm telling you about I went to the beach and the water was really cold.
A sense word is?
Words related to senses, the hear, the see, the feel, those are the senses. For example, you can the examples. Okay, so let's look at the sense words. Ocheadă, privitor, there are from hearing. Pălăvrăgea, râzi, there are from seeing. Înșfacă și rece, they are from feeling. Because when something înșfacă, you feel it.
Înșfacă, da, se întâlnește înșfacă.
It's a weird categorization if you ask me, because there are words, for example, nespus, it belongs to the hearing, but it doesn't mean quite that. For example, te iubesc nespus, it means I love you very much, but they consider it as a hearing word, and I do not really believe that's true. So there's also a problem with the LYWC lexicon.
Very hard topic. Okay, thank you.
Can you please try to imagine the real-time system working, for instance, in a classroom when we are listening to the work of students in a lab, for instance, or something like that? Could your proposal work in real time? Are there any limitations that you can see, for instance, content recognition, like, I don't know, maybe some words, the ontology of the words, the significance of them. Can you try
the
to
problem
extend
with
on
this approach, let's say, is that, for example, it does not study the content of what you are saying. For example, as my colleague mentioned, the negations that change everything in their way. Also, it is very difficult to consider that someone is lying without knowing how they are telling the truth. That's a general problem of this approach, because you are not comparing me lying with me saying the truth. You are comparing the whole corpus of lies with the whole corpus of truths. So that's not really a personalized approach to the, let's say, the linguistic avatar of a person. So.
And you've also mentioned something interesting, that you could extend this proposal by using automatically analyzed emotions.
Yes.
What do you
for example, it's considered that a liar is a very negative person. For example, he's not very optimistic because in psychology, overall, it's considered that he carries so much hate, let's call it, that it makes him being very irritable, very angry, and you can see that from his language.
Mm-hmm. And technically speaking, what do you think of using? Facial expressions or something else?
Body language, yes.
Okay,
for example, a study that I read some time ago used both court testimonies and compared just the linguistic features, the body features, and the combination of both. And the best results were obtained on a combination of the two of them. So you should also follow and be somehow attentive to the body language, but also what that person says through their linguistics.
Do you see any correlation with physiological responses?
Yes, there were some researchers, for example, they try to, let's say, put down lie detectors because they use temperature and heart rate. But for example, I suffer from a condition and I have a very high heart rate. For example, now I think I had, I don't know, 140. So I'm not lying, but I am sick. So it's not very reliable in that sense.
Maybe heart rate variability. Okay, thank you.
One ethical question. Ethical question.
Yes.
Is it possible that your system to be gender biased?
We can consider that because there are some studies that say that, for example, generally, again, men tend to lie more about their professions, their education, their more, let's say, academic characteristics, while women tend to lie more on the sentimental or emotional part of their life. So they tend to lie more, for example, about their feelings, not about what they do.
Okay, this is reality, but your system, maybe your system tends to attach more liars to, I don't know, men or women.
My Google form did not contain any personal information, but I do know, for example, some of the personal people that wrote in that Google form, and I, let's say, tended to see this for what I mentioned about women lying more about their personal life and their feelings, and so it may be possible.
It started to be important that this kind of system to have this kind of verification against different biases. Okay, thank you for your presentation and work. We invite the next speaker and I'll propose a short break after that, 10-minute break for coffee or something like this. After this, the next presentation.
Giovanna Maria, stock market prediction using LSTM, correlations and future sentiment analysis.
Thank you.
You have it. It's test.
Hello, my name is Giovanna Maria, and my paper for today is called the Stock Market Prediction using LSTM neural networks based on sentiment analysis and price correlation between stocks. This paper was realized by me and my coordinating teacher, Tonino Viducena. Here are the table of contents. We will start with a short introduction, system architecture, experimental results, some future improvements, and lastly the conclusions. Introduction. The context of this project is that in today's world, the traditional ways towards predicting stock prices are limited and constrained by a variety of external factors. By these external factors, we can consider politics, company statistics, company events, and also the sentiment of the people about that company. What is stock market prediction? As a short definition, stock trading is the act of attempting to predict the value of another financial instrument traded on a financial exchange. And the stock market field is well known for the non-linear dynamics and unpredictability and dynamics. The goal of this research is providing an accurate estimation of a stock price, which can result in significant benefits and market opportunities and also financial benefits. Also, another goal that I mentioned is to see whether the attributes of stock market correlation networks, as well as feelings extracted from social media like Twitter, can be utilized to forecast market dynamics over time. What we propose in this paper, we propose the hybrid system using a standard stock market prediction with deep learning and adding as input to it some correlations between stock prices and also the sentiment analysis gathered from Twitter. Some details about our approach. As you can see in this picture, we use the FAM group for testing instances. The FAM refers to Facebook, Apple, Amazon, Netflix, Microsoft, and Google, which is a group of 6 companies that have majorly outperformed the market in the recent years. This acronym is very used and can bring a lot of financial benefits if we can predict the price is good, because those are one of the most expensive and popular stocks in the stock exchange. The system architecture. This study is represented by a hybrid prediction algorithm that uses as input to LSTM the sentiment analysis and some correlations. We have basically 3 approaches. The basic approach doesn't use neither sentiment analysis, neither correlations. After we have an approach using basic stock price prediction based on historical prices and adding correlation. And the final version has all 3 sentiment analysis, all stock prices and correlations, which is the final version and the suggested way to use this. Here is the system architecture, and the short explanation to it is that a broker or a person interested in investing uses a query, which I will explain you a bit later what is. And this query arrives in the data frame builder. The query is basically, you can use as query, for example, if you're interested in Amazon, you can use either the CEO of the company as a query to retrieve tweets, or the company name Amazon, or the stock name, which is AMZN. This is how it's called in the stock market. After that, the query request on Twitter API and retrieve the tweets from Twitter app. After that, we have to retrieve the stock prices, the actual stock prices. We use the Yahoo Finance API, which we do a request to it, and we get the stocks data back as a response. For the correlation, we use the stocks data and use the correlation builder in order to retrieve a correlation score. After that, for the sentiment analysis, we use the tweets as an input. We pre-process the tweets. After it, we get the processed tweets with the sentiment analyzer. And in the end, for the machine learning training model, we use those 3 inputs. The learning architecture, the model's learning architecture is made up of the following layer: the LSTM layer. We add 250 units to this layer to basically predict 250 days. The dropout layer, because there might be some data, some extra data, and we want to cut some of it. And the dense layer, which is the most commonly used layer for it. The learning method used is Adam. Adam is typically picked as the best overall option for the time series problem, and since stocks data are time series problem, we chose this one because it's a good optimizer and has the benefits from other optimizers. And I also read on the internet that it's most commonly used for stock price prediction. And since we had a large data set, we used 150 epochs and 32 batch size for the learning process. The prediction architecture consists of 3 parameters: the stock prices gathered from each day when the market is open, because the market isn't always open. In the weekend, the market is closed. The correlation of the given stocks and sentiment analysis. First of all, the correlation. The stock correlation is calculated by using Pearson correlation, which takes values from -1 to 1. And it is used to determine the strength of the correlation. For example, if the Pearson correlation is 1, they have a strong correlation, and for example the stocks grow in the same time together. The sentiment analysis, the data is retrieved from Twitter. The method for analyzing sentiment is the start date, the end date, the query which I mentioned before, and the maximum amount of tweets that we want to use. As I mentioned before, the query uses stock name, company name, or the CEO of the company. After that, we do pre-process the tweets from Twitter by removing the usernames from the people, the links, the emojis, the blank spaces, so we don't have dirty data. Each tweet is after that classified and labeled as positive, negative, or neutral with a pre-trained natural language process model. The resultant score is calculated by dividing the number of positive tweets by the total of number of tweets for that company in that day. The experimental results. First of all, I wanted to draw a correlation graph for those 6 companies that I mentioned before, the family companies. And this is the resulted graph. In the right top corner we have the legend of it. And we can see that all those companies are related. That fact is because all of these companies are from the technological sector and it is somehow normal to be correlated. After that, I chose only one stock to present in this PowerPoint. The stock I chose is Amazon. And here we can see some predictions made for the 2021 and 2022 year for this stock. We have the date, the predicted price, and the actual price. Also here we have a graph still for Amazon. This graph is used by made with correlation, sentiment analysis, and stock historical prices. And in comparison to this, I will show you in the next slide the other 2 approaches. So here we have, in the first drawing, we have stock predictions with correlations. And in the right picture, we have the stock prediction without correlations. We can see that the prediction, even on the graph with the sentiment analysis, is way better than without it. The red lines is the predicted value, and on our approach is very similar to the actual price of the stock. We also calculated the mean square error as a metric for those 3 approaches, and obviously the presented method gave the best results to it. As future improvements, we thought about retrieving sentiments from multiple sources like newspaper and other trustworthy sources, because this is somehow retrieving Twitter information can be somehow tricky because it allows everyone to post whatever they feel, and it's not always the truth data. Also, we thought about studying the financial crisis and how the algorithm works in financial crisis. And also, as a third future improvement, we thought about finding interesting correlations between companies from different sectors, since we only studied the information technology ones in this paper. The limitations are unavoidable in these studies. According to the restriction of the study, the selected stocks must be openly traded on the stock market, so we can't predict some stock which isn't on the stock market. Furthermore, unlike Twitter, which is always available, stock market has different opening hours, which can be also a limitation. Also, the posts from the people on the internet are limitations, and many more of these, but these are unavoidable, unfortunately, in this field. As a conclusion, experiments on Amazon stock indicates that the proposed approach may enhance forecast even more by simultaneously analyzing correlation and sentiment gathered from Twitter. This study is considered valuable in introducing scientists to the topic of stock market prediction using correlation networks as well as sentiments. Here we have the bibliography of the paper, and thank you for watching this presentation.
Thank you for your presentation. Questions if you have, please.
I have one question. So if you said this already, I apologize. But I was actually curious. Do you consider, basically, if I'm going to tweet something and I'm just going to put the hashtag Amazon, you're going to consider it by default with filtering me
filter the data from Twitter by keywords. For example, if you use a hashtag with Amazon, we will consider it. After analyzing with a pre-processed trained model, we will label it if it's useful or not. For example, while testing these case studies, I received some weird Twitters like about Kim Kardashian and with hashtag Amazon or Google just to gather attention from public, but they weren't labeled as being useful after those criteria.
Other questions, please? You have a table 1 with Amazon prices.
Yes.
You use mean square error for your
Yes.
prediction. Assume that instead of your heavy machinery of machine learning, deep learning, I use a simple rule-based system with one rule, which says I will predict the price 0.5 above and below that value. And if I use this simple rule, I think that the mean square error for my system is better than yours. Do you agree? Or because you see that the values are very close.
Yes.
The value is 176, and my system will predict 176 random within that interval.
Yes, I agree. I only use the mean square error to compare these three results because also mean square error is it's not really that good on stock prices because only while comparing the same company. Because if I compare Amazon, which is a lot cheaper than Google, the mean square error won't work that good. So I also have a May metric, but I didn't put it in this paper. I mean, this mean square error, I only used it for to show the benefits of this approach on one company. So it's not good if I compare with mean square error the Amazon stock with the Google stock, for example. Because the prices are very different between the stocks. And also the results won't be relevant.
Thank you.
I have 3 questions.
Yes.
One, you've mentioned that you've cleaned up the tweets from emojis.
Yes.
Sounds so. Can you comment on that, since you could maybe consider them in evaluating the tweet as being positive, neutral, or negative?
No, I didn't consider them as being useful because the emojis can be very different, and I didn't find a way to interpret them because, for example, some of the tweets had a flower in them, which I don't think it's relevant for our tweets. So I decided to remove everything that wasn't good, to only let the tweet text. So no username, no links, no white spaces, no.
Oh, that's debatable from my point of view, but yeah, I understand your point. Can you evaluate the difference in impact between the sentiments in a tweet, or in tweets in general, that you are monitoring, and a strike, for instance, or a stock delay, a delivery delay?
I didn't understand really.
I mean, you take into consideration stock variations,
Yes.
okay? And when there are, for instance, like a current of ideas on tweets, like this is something going on, and a lot of negative, or even on the other side, positive sentiments, then you have an impact on your stocks. That should have a certain impact. And also there is an impact when a strike is going on, or when, for instance, now in China there is a stock delivery delay. That's another impact.
Yes.
Could you measure, not measure, but could you maybe estimate the difference between them? So what's the impact in one case and in the other?
I didn't measure the difference between this, but I think that if we compare only a certain amount of tweets, maybe, for example, I have a parameter which says which I can put to get a specific number of tweets, so don't only get the floated or the strikes one. I didn't think about it. But I think that as a future improvement, I can also think about it.
And the last question.
Yes.
How can you envision using your proposal to, for instance, something else like currency value variations?
For example, with this approach, we can analyze other things like also the crypto market with a proposal like this. And I think that for example, this approach is good for only predicting for example, I can predict for tomorrow based on tweets that don't exist today. And I think that's a big downgrade of it, but also, for example, if today we post about something relevant to Amazon, this will be still valid tomorrow.
Okay, let's send the speaker for the presentation. The next paper is about trade anxiety, but we propose to trade this anxiety with a coffee break for 5 minutes, and after that Victor will trade anxiety with genetic programming. 5 minutes break for coffee. Please help yourself there. related to emotions.
Yes.
Victor will be the presenter for Babel Korea University.
Right, let's see. Okay, should be good. So I'm going to present a paper that's called Biomarker Discovery for Trait Anxiety via Genetic Programming. So as you can probably already tell, this is an application of machine learning on the biomedical field. More specifically, we're doing this on psychiatry. We're concerned about anxiety. And so to start off, biomarkers are measurable indicators that we can extract from our body, and they can tell us whether or not there is an illness or disorder present. You know, this is very important to research because they allow us to essentially diagnose people before those illnesses even get the chance to manifest. And more so, it actually gives us insight on how all of those different illnesses or disorders function when they affect us. And so this paper tries to, or the study tries to do this, tries to discover biomarkers for trait anxiety. Trait anxiety is a subclass of anxiety, and it refers to a persistent fear for things that are not usually threatening to us. And the way that clinicians currently diagnose this is through a test that is called the State Trait Anxiety Inventory. You know, in psychiatry literature, they actually make a point to talk about the regions of the brain that are known to be responsible for anxiety. And some of those are the hippocampus, amygdala, insula, and then two cortexes, the prefrontal and the cingulate. Those are things that I'm going to be coming back to, so you don't have to remember them. As far as this paper is concerned, one of the main motivations that I had for approaching this topic is just the sheer fact that there's not a lot of approaches currently out there. Like, this is a niche within a niche within a niche. And so, you know, being interested in psychology and psychiatry, I would have liked to see more machine learning approaches for this, and I wasn't able to. And so I thought, well, let's just try to do it on my own. And the objectives that I set out to do for this is essentially to try and see if genetic programming is able to detect those regions of the brain that I talked about earlier, the ones that I enumerated with the hippocampus and the insula. And furthermore, if the algorithms are able to do this, then we want to see what else it uncovers, right? Like any other potential biomarkers. And throughout all of this, we want to pay close attention to the performance metrics that we have for our classifiers. We want to see how well it can manage to classify trait anxiety on our data set. So our inputs are given by MRI files of patients, and the way that we are going to use those is, I don't know if you know this, but an MRI file is a digital file, right? And it gives us all kinds of slices of the brain, you know, as you can see in this picture. But essentially what we do when we want to apply machine learning algorithms and we want to get morphology statistics from the brain, we run this through a software called FreeSurfer. And this software takes an MRI file as an input. It spends about 6 hours processing it. It's a very complicated algorithm, and it outputs all kinds of tables. We can use Python to just make a script and aggregate all of those together, and in the end we have this huge table with more than 1,000 columns which describe different brain measures for each of the input patients. Now, we are doing this project on a dataset that was published relatively recently. It was published in 2020. It's a collection that has one large study that actually approaches trait anxiety. And so it has almost 1,000 subjects, roughly equal in terms of sex. And it provides us with the FreeSurfer data as well as the questionnaire scores for anxiety. What we're looking out to do is we try to turn this into a classification test, so whether or not someone is suffering from anxiety or not. We end up with this threshold of 45. So the score of this anxiety test goes from 20 to 80. And in the manual, we have a normative value that is given by the researchers. And they say that if you have a score that's bigger than 45, then there's a very high chance that you might have trait anxiety. And so after this, we end up with around 700 controls and 234 anxious people. What we set out to do is implement two algorithms, two genetic programming algorithms, one that selects features and the other one seeks to engineer them. So a couple of words on genetic programming in general. This kind of technique, what it allows us to do is generate random solutions that evolve over time, right? So over the span of a couple of generations, we might hope to get even better results. And they're very, very flexible. They can be applied to most anything. But
overall, what I saw was that this technique is used mostly in omics data projects. So we're looking at things like gene expression when they're trying to classify cancer. And in fact, I have two examples here with oral cancer and carcinoma where they have pretty impressive results, like 91% sensitivity. But the use of genetic programming is not relegated only to those, only to this niche of omics data. There have been plenty of efforts done in psychiatry, like the case of Alzheimer's disease, where they actually use genetic programming to select features, to filter out the data set, and they managed to improve the classification accuracy from 87% to 93%. As far as our approach is concerned, what we want to do is we want to test a support vector machine classifier, and we want to do so by changing the kernel. So we're going to run 10 experiments per SVM kernel per task. So that amounts to around 80 experiments. The way that we evaluate our solutions is through the accuracy of an SVM classifier, but we want to test the stability of the model, so we do something called bootstrap aggregating. In the end, what we return for each individual is the SVM accuracy, the mean of it, over the iterations of the bootstrapping mechanism, and we penalize it by the amount of active features in the solution. Then this is done just to promote solutions that are shorter, smaller, more easily to interpret. So this is the first implementation that I have, which is the feature selector. And in this case, what we do to encode our solutions is we use vectors of Boolean values. The value at one index is going to tell us whether or not that feature is taken into consideration when we train the classifier. So as you can see here, the second and the fourth features are taken and given to the classifier. In order to add variability to the population, we have mutation and crossover. In the case of mutation, it's actually called bit shift mutation, where it's just a probability that a random feature is going to be either eliminated or taken into consideration. Like we see here, the fourth one gets shifted to false, and this is a very slight adjustment. When it comes to crossover, we just have the right side of a random index exchanged between two individuals. As you can see here, first true value went to the second individual, the second individual false value went to the first one. After running 40 experiments on this, 10 for each kernel, as I've mentioned, what we did is we ended up getting a maximum fitness value of 0.65, which roughly equates to 65% accuracy, because the penalty is fairly small but effective. And after we did that, what we sought out to do was try to get all the solutions that were at least a little bit promising. And so in this case, what we set was a threshold of 0.6. We got all of the solutions that had a score higher than that, and we created something called a frequency table that you can see on the right side. In the case of this table, I've highlighted some features, and thankfully you can see them there. The ones that I highlighted are actually the biomarkers that we discussed earlier in the introduction. So over here, the feature selector was able to identify the insula, the anterior cingulate cortex, as well as the hippocampus. Now moving on to the second implementation. We'll come back to the biomarkers that we identified. The second implementation is fairly different because in this case, we are encoding our solutions with a structure that is called a binary expression tree. And in order to add variability to this, the crossover is just going to be, changing members of the equation between individuals. And then with the mutation, we're either going to change the operator, so we're going to have an operating mutation, like in this case, division becomes multiplication, and the label mutation just chooses a random feature and replaces it with another one from the data set. In the case of this task, after running the experiments, we got some results that were a little bit more optimistic. We got a maximum fitness of 75.63%. You can think of it as the accuracy yet again. And essentially, one of the more surprising results in this case was the fact that the very best constructed feature actually contained the cingulate cortex. Apart from this, we also got two other insula measures in the top 36. And probably one of the more interesting things that we see here, which is an analysis of the patterns, is the fact that the entorhinal cortex area is present in 35 of the 50 best engineered features. So if you go back to the feature selector, we also see that this is present, and it's the 18th most frequent feature that we discovered. So they kind of play together. So just to kind of recap what we've done with those experiments is, in the case of feature selection, we set a threshold. We try to get the most promising individuals that we created randomly. And then, after making the frequency table, we just apply some statistical methods like the 90th percentile to extract, the most frequent or the most informative, what we consider to be the most informative features, and we forward those as potential biomarkers for trait anxiety. When it comes to feature engineering, it's a little bit more simple because in that case, what we do is we just create a hierarchy of all of our constructed features, and we forward the best constructed feature, of course, the components of it, and then we also look at some patterns, like what we saw with the entorhinal cortex area that is present in 35 of the 50 features. And we forward all of those as biomarkers. Now, this might seem a little bit convoluted and not something that you see daily in machine learning projects because many of them just try to optimize classifiers and not necessarily doing this kind of analysis. But this is something that is done in literature. So for instance, I have here a alcohol dependence prediction task, and I have 2 papers regarding this. The authors of this first paper, do very much the same thing that I did, and it's funny because I only found this much later after I've done this. And they do this again on brain morphology data. It's very similar to what I did. They just have some additional stuff that they did in order to gather feature importance metric. But it's still based on the 90th percentile and setting a threshold through which we filter the individuals that we create. Apart from this, in the second approach to alcohol dependence prediction, what they did is they trained the classifier on the entire data set, and then they just kept taking out features and try to see how that affects the accuracy of the classifier. And that's another way they can go about it when you're trying to figure out which features are the most important as you're classifying something, especially a disease. Apart from this, there are several other ways that you can do this. You can look at the coefficients of an elastic net. If you have random forest and you're using the sklearn implementation, all you have to do is type dot feature importance and you get the most important features. And then there's also Shapley values, which is a technique that you can apply to any kind of model, and it tells you which features drive the prediction towards a certain label. So finally, the table that contains all of our forwarded biomarkers is here. We have the best constructed feature below. We have the most frequent features that were discovered by the feature selector. We have the components of the first, of the best expression that was constructed, along with the most frequent other measures found in the top 50 constructed features. And now to wrap this up, what we've eventually discovered, or finally discovered, is the fact that genetic algorithms are capable of finding most of the biomarkers currently known for trait anxiety. It has predictive power greater than chance, so it certainly finds some patterns in the data, but this is not powerful enough to actually drive high precision for classifying trait anxiety. So this is not advisable for, say, we can never dream of this replacing a doctor because it's not good enough. And so further work in this, in the scope of this paper is to, perhaps run more experiments, and really consolidate all of the analysis that we've done. We can deploy this to cloud servers with more powerful hardware that can withstand higher parameters for our genetic programming algorithms, because the truth is I was very much limited by the hardware that I have. I was running all of the experiments locally. And then apart from this, we can be a little bit more wild and experiment with not a classification task, but a regression task. Perhaps try to predict, instead of a label like whether or not someone has anxiety or not, we could predict the trait anxiety score from the test. And last but not least, there is one discussion that is particularly long, but I did have a line about this, which is to apply the same method to a clinical data set, not a general population data set. Because part of our, I don't want to be pessimistic about our results, but some of them can be attributed to the fact that we're doing this on a general population data set where we're not really accounting for any official diagnosis. And there's a couple more things to say, but I'm going to let you ask me. And that concludes my paper, my presentation. Thank you.
Thank you for your presentation that I found very professional and very confident.
Oh, thank you.
Questions if you have to. We could start with some questions. The poorer features are extracted with free sulfur, all the features.
All the features that we get, yes. So when we have them, do you want to continue the question?
Okay, this was just to be sure that I understood.
Sure.
Okay. and after that you use genetic programming to rank the features, but also do you generate new features by combining these basic features?
So what I do, I have two implementations of genetic programming.
Feature engineering means that you
Yes, I'm constructing. So I'm making like
construct new
volume of the brain divided by the volume of the hippocampus, things like that.
And what did you find? What
Well,
features?
Sure, I'll go back. It's essentially this table here. I don't know if you have my papers somewhere they're printed because
Yes, we do have it.
it's more readable over there.
Yes,
I'm
yes.
sorry.
So if you
Yeah. And so it's the cingulate cortex divided by, you see, like an angular volume. And we discovered this as a ratio, so it's two features. This isn't penalized very much. And this is what we found to be like the most powerful way that we can predict trait anxiety on the ID1000 dataset, which has a fitness score of 0.7563. So this is one of the discoveries from feature engineering. And then with selection, you mentioned that yes, what we're trying to do is we're trying to find like combinations of different parameters in the brain that can explain trait anxiety. Like for instance, one thing that we can hope for is that, you know, perhaps the white matter in different areas of the brain, perhaps they can contribute to finding or to understanding whether or not someone has trait anxiety. That's kind of what we're looking for. Because if we see those measures turn up with really high frequency, you know, you can kind of corroborate all this information and, you know, give it to a team that actually knows what they're talking about. Because I don't have a degree in neuropsychiatry. I wish I did.
Now you are using this local search. The local search is guided only by the fitness function.
Oh, actually by a lot of things. First and foremost, yes, the fitness function plays one of the most important roles. Because again, what we have in the fitness function, we have the accuracy of an SPM classifier, and we penalize it by, God, where is it? We penalize it by the number of features. So again, it promotes solutions that are very short. So we're not going to see, like in the first place, a solution that has 20 features, because then how do you interpret that? It's a little bit hard. So this drives the algorithm to find good solutions. And then another thing is, you know, over here I have the parameters, and from generation to generation, what we want to do is we want to change each individual. You know, we have the probability of it undergoing crossover mutation.
That's the parameters of the
Yes.
genetic search. In this field, you have expert knowledge.
Yeah.
How do you put this expert in the loop, human in the loop, such that the search process to be guided by some intuitions or expert knowledge?
Oh, interesting.
Where do you put that in your system?
Well, it depends. So you're asking, so I'm over here, say machine learning engineer, trying to apply this, and then how do I incorporate like domain knowledge from psychiatry? And how can a psychiatrist chime in and say this? Okay, interesting. Or the reason why I said that was interesting is because usually when we're applying this, what we're trying to do is we try to let the algorithm figure it out. Like we're not trying to bias it towards certain things, right? Because for instance, currently we do know that the hippocampus is influential for anxiety, but we don't really want to promote it. Like we want to see the algorithm figure it out on its own, right? So this was kind of the analysis that I was doing here. But essentially, if you do want to do that, you can get, you know, knowledge from a professional. They can say the hippocampus is very influential, and then the amygdala is very influential, but not as much as the hippocampus. And then one thing that you can do is you can attribute some weights to those features. You can make it more probable that the algorithm goes towards that region of the search space, you know?
So basically, you will alternate this fitness function somehow.
It's going to be incorporated somewhere in there, yeah, for sure.
Okay,
Yeah.
thank you.
Yeah, thank you.
Well, it's very, very interesting work. That's for sure kind of difficult to process this from my side. How can this solution be generalized? I mean, there is anxiety, that's for sure. There are some other disorders that could benefit from your approach.
Interesting.
And also, I was also thinking of what you said. So, human in the loop, I think it's very important. And at some point, maybe that could be a solution to better understand a certain group of people, and that's another part. So, scalability in that sense, so to other disorders, but also to make it more focused or more precise, not personalized, but calibrated to something particular. So, can you comment on that?
Yeah. I feel like there's like 1,000 things to say. I'm trying to collect my thoughts, but essentially, First and foremost, you asked about generalizing the solution and if there's anything else that can benefit from this. Essentially, every single thing that I've done to implement this, because I did it from scratch, is made with those MRI files in mind. So even if we approach fed anxiety, or we have depression, or we have borderline personality disorder, the inputs are going to be always the same. And the way that we generate individuals were, initially, for instance, for the Boolean mask, we're trying to make sure that we have, in the beginning, an average of 10 features active. We're not going off of, like at the beginning, we're not going to have 100 features and we just cut them off. We start off with a small amount and we try to optimize it after. So yes, the implementation that I have can be generalized to most other inputs, so we can apply this to all kinds of different tasks. Then your question was if perhaps the results can be generalized or if they can help other things. In the case of trait anxiety, perhaps if our data set did not have trait anxiety but it had an official diagnosis for anxiety, then it would have definitely helped, because when it's that general, what it does is, the DSM-5, which is the highest authority in psychiatry, they give you like a list of, say, anxiety disorders. You're going to have selective mutism, you're going to have generalized anxiety disorder, you're going to have, all kinds of different things, like phobias go in there. And so something like this can, all of those are going to fall into the same label, essentially. So it does generalize to a lot of different subclasses of anxiety in that case. In our case with trait anxiety, it's very, very specific. All that it does is, if you get if someone tells you they do have a high trait anxiety score, then the only thing that you can derive from that is that you have a high chance that in the next years you're going to start suffering from an anxiety disorder, and that's about it. Yeah.
Well, the features are extracted from images.
Yeah, so slices of the brain. We have, I think, 3 axes. Yeah, 3 axes.
Usually physicians use other features too, like discussing with the patient.
I've seen something, and it was actually what inspired me to start learning genetic programming. It was some study that was done in South California where they had a data set comprised of MRI files from children. And what they were using was a lot of other parameters, like social parameters, like how much adversity that child had gone through. And what they discovered is that they can link that to a certain region in the brain. And I don't remember if it was like a constant multiplied by it and then divided, but essentially was able to explain depression in kids fairly accurately. So yeah, you can definitely incorporate all kinds of things. One of the biggest troubles that I've had with this kind of project is the fact that generally we don't have huge sample sizes. And so in the beginning, I was doing this on depression. I was trying to recreate that study because they didn't put out a paper yet. And I kept asking for data sets from researchers and they wouldn't give it to me because I wasn't part of a research lab. And I had a really painful time with that. And I forgot what I was getting at. Just a lot to say.
Thank you again for sharing your work.
Thank you. All right.
Okay, we invite Pet Pucarina with the paper Art Regarding Emotions. We have a very emotional oriented session here. So artificial intelligence is related to human emotions.
Can you see my screen? Okay, perfect.
Yes.
Hello, my name is Pet Pucarina, and today I'll present you the paper Multi-Feature Facial Emotion Recognition, combining convolutional neural networks with optical flow-based action unit detection. In the introduction, I will answer to 3 questions. What, which refers to the context of the paper, why, to the motives, and how, to the original contributions. We use emotions every day, even if it is conscious or not. And Paul Ekman was one of the first people to study this. He's a psychologist, and he defined the 6 basic expressions, which are sadness, disgust, fear, happiness, surprise, and another one. And we can also add the neutral state. Moreover, besides these basic expressions, there are multiple that can be defined. For example, in the book of Human Emotions by Tiffany Watt-Smith, 154 different feelings are explained. For example, wanderlust, which is a strong desire to travel. And the facial expressions are very important because they can show how we are feeling without verbally expressing them. But unfortunately, the therapists during sessions with patients, they cannot focus on the expressions that the people are showing. So we came up with this solution that shows up two ways of detecting the emotions on human faces. One which is a conventional one and a CNN-based one. Moreover, we compared these two methods between them and with already existent methods. And finally, we provided a web application to the therapists to make it easier for them to detect the emotions on patients' faces. Moving on to the already existent work, first of all, I will mention the facial action coding system, which was initially proposed by Hirschow and then was adopted by Polakman and Friesen. So what this facial action coding system does is to divide the facial musculature into 46 components, which are called action units. Moreover, I will also mention a division of the already existent facial emotion recognition methods. The first one, which is the conventional one and is based on using images and extracting features from them, and then using geometry or physics, we get the emotions, while the deep learning ways use CNNs or LSTMs to detect the emotions. And I will also mention two existing methods. So first of all, we have the one proposed by Ackhand. So they saw that using a shallow neural network leads to worse results. So they proposed a deep CNN model. And moreover, another novel thing was the pipeline of the model that shows that the pre-trained CNN blocks follow the training of the dense layers. Another paper would be the one proposed by Hossein et al., which is presenting an unusual transfer learning model, but several areas like healthcare, emotions, and social are combined into one facial emotion recognition system. Moving on to the proposed solution, here is the pipeline. So we can see that we get a video as input from the therapist, which is then divided into frames, and then the processing part starts, where we first of all detect the faces in a certain frame, and then depending on the choice of the user, we either detect the emotions using a conventional method or using a CNN-based one. First of all, I will start with the processing phase of the face detections. There are multiple algorithms available, but the one that I use is the MTCNN one, as it was the only algorithm to not only detect the frontal faces, but also the ones that are on one side. Since the pre-processing was done, we will continue with the emotion detector, starting with the conventional one. Here is the pipeline of the conventional detectors. So we get the faces from the face detection, and then using those faces, we will detect the landmark points and the optical flow. And these two are not are independent from each other, so they do not depend on each other. And using the landmark points and the optical flow, we will get the results, and we will compute them to get the emotions. First of all, the facial landmarks detection, I chose the method developed by Kazemi, and this one determines 68 facial landmarks. And the idea is that the input is only one image, and these points are determined depending on the intensity of the pixels. And these points will be used for the detection of the action units. Moving on to the optical flow detection, so I use the dense optical flow, which determines how all the points from two frames move between these two frames. So this method, based on the Gunnar-Vannerbach, returns the magnitude and the angle of every input point. And to make it easier for visualization, as we can see in these two pictures here, we use an HSV image for visualization, where the hue is the direction of the movement of a certain point, and here we can also see the fact that these three people move in different directions, and the colors are different depending on the motion. And the value is the normalization of the magnitude, which represents the intensity of the movement. Having already detected the landmark points and the optical flow, we compute the results to get the emotions, and how and this detection is based on Paul Ekman's action units, but the current algorithm, out of the 46 action units that are defined, we detect only 13 because they are the action units that compound the 7 basic emotional states that I presented in the introduction. And the landmark points are used to get the specific area for the action unit that we are interested in, and the optical flow is to show the movement of that area. And for example, for action unit 1, which is the inner brow raiser, we get from the landmark points the inner corner of the eyebrows, and then depending, and we check for an upward movement of those points. And moreover, we also check for a low intensity because in the case of a high intensity, this means that the frames were like very far apart, so the detection might not be accurate. Moving on to the CNN-based detector, we use the transfer learning and fine-tuning to get better results in regards to the accuracy, and the transfer learning was done using the pre-trained models like MobileNet V2, EfficientNet V0, and VGG Face. And the development model can be divided into 3 phases. So we have the data processing, the feature extractor, and the classifier. The feature extractor and the classifier are usual for a transfer learning model, but the data processing does not only have the data from the data sets, but also we added the data augmentation layer such that the input is more diverse. So for example, the image are flipped, rotated, contrasted, and transliterated. And after several experiments were done, we chose the EfficientNet V0 model because it had the best results. And now moving on to the experimental results, where I will present the trainings that were done considering the base models, the comparison between the CNN model and the already existent and the 2 proposed models. So for example, I will start now with the datasets. We used 4 datasets, out of which 3 were image datasets and 1 is a video dataset. So we have the image datasets KDF, JAF, and AffectNet, and the DISFA dataset for videos. Here we can see the trainings of the models. We used different models with different datasets, and we can observe that the best results regarding the accuracy were obtained for the EfficientNet V0 with the KDF dataset of 83%, and the VGG Phase 1 with the JAF dataset with an accuracy of 86%. We decided to go with the first model as the KDF dataset is more diverse than the JAF dataset, which presents only 10 Japanese women. And here we also have the training and the validation accuracies during the transfer learning and during the fine-tuning, and the confusion metrics of this model. Moving on with the comparison with already existent models, so we can see that the paper proposed by Hossein et al., which is the one having the facial emotion recognition system, had an accuracy of 80.92%, while the second paper had an accuracy of 98%. 98.78%, and our proposed solution with 83% is situated between those 2. And now comparing the detectors, the proposed detectors. So we use 4 videos from the DISFA dataset, which show people having different genders and being from different races. And every video had a length of 242 seconds. And we saw that the average time was similar for both the detectors, with an average time of 80 minutes and 20 seconds, which is 4.5 frames per second. And here we can see that we can make several observations. First of all, it is worth mentioning the fact that we couldn't compute the accuracy of the conventional method because this data set is for action unit detection and not for emotions. So we made the observations depending on the graphs and the videos. So we can see that both the detectors have a certain bias for an emotion. For example, for the CNN model, we have a bias for the anger state, while the conventional model has a bias for the neutral state. But even though with this bias, we can see that the happiness state is equally detected, and also disgust is not that different. And another observation that can be done is the fact that the conventional method seems to be prone to detecting the disgust, happiness, neutral, and surprise states, while the CNN detects a more diverse range of emotions, for example, anger, disgust, fear, happiness, neutral, and sadness. But this is also because the CNN model is detecting only the emotion from one frame, while the conventional method is a dynamic way, and we are using the emotions from 2 consecutive frames. And here we can see a bit screenshot from the application and how it looks like after the video was uploaded and all the computations were done. So for example, we can see this video of a Caucasian woman, and the chosen method was the conventional one, and from all the frames, and we can see here the graphics that were resulted from that video. And in conclusion, so we proposed 2 methods for detecting facial emotions. One which is conventional and is based on the action units of Paul Ekman, and one CNN-based one using transfer learning. While comparing these 2 methods with already existent ones and providing the web application. And for future improvements, there can be, so the results were promising and they can be improved through future improvements. For example, for the conventional method, for now we are focusing only on one point from the facial landmarks, and an improvement could be to use a neighborhood of points, and also to detect more than the 13 action units that are detected right now to increase the range of the emotions. And for the CNN model, we could improve by using a CNN plus RNN model such that the detection is also dynamic like the conventional method. And thank you for your attention.
We thank you for your presentation. We have time for questions, please.
I know that many data sets in this field are very unbalanced. In the case of emotion they present, is this the case of the data sets you used?
No, so the KDF and the JAF databases are not unbalanced. The AffectNet one was, but I saw which was the minimum number of emotions for one state. So for example, it was around 3,600 for anger, I think. And then I chose, I balanced the data set by using only the specific number for all the states, the emotional states.
Other questions, please? You mentioned that you compute some bias between the technologies, no?
Yes, yes.
Between deep learning and...
So we have anger for the CNN and neutral for the
So
conventional.
CNN tends to assign more anger than the
Yes.
other one. An ethical question. How do you know that, for instance, black people, your system will attach more angry to black people than the other race?
The KDF database, I think mostly has Caucasian person, but for example, if we were to choose a model trained on the AffectNet database, there are images having all kinds of races and different genders, so it is more diverse.
Okay, it is diverse, but maybe your system they are 33% black people, and your system will attach negative emotion to that people more than the other in the database. And you need to be very, very cautious about this.
Well, I think that this depends on the data sets and how the images are labeled from the people of different color. And how the model is training.
It depends on the machine learning algorithm, because it might have difficulties there and it tends to attach more errors to specific races.
But this is also why we have the conventional method, because this does not have a bias, because we only compare the landmarks and we see how they moved. So it doesn't not really depend on the race, but on actually how your face is and how good those landmarks are detected.
Thank you.
I have several questions. Maybe we will continue the discussion afterwards, but I will just try to point the most important ones. A brief question about table 1. There is a correspondence between the basic emotions and the action unit. I don't know if you have it on your slides, but it's in the article, and I wanted to know if, as there is no reference there, if you have deduced somehow the correspondence between them, or is taken from somewhere and without the reference, or maybe it's generally.
Regarding the action unit detection?
Yes, the correlation between the affective states, the emotions, the basic emotions, and the corresponding action units.
Yes, they are mapped, and I think it is called the facial action. So there is a.
So it's not your contribution.
No.
Okay, so it should be cited.
Okay,
That's just one. I would like to know what's a reason behind choosing a certain list of databases. I mean, that's very old. And I really appreciate the fact that you are doing something in that area with optical flow and action units and things that are kind of on the classical side, which is nice. But I wanted to know, again, what's the reason behind taking into consideration those databases? For instance, I would say it would be interesting to have MMI, Concatenate, and maybe some others.
Yes, I thought of MMI. Only the problem was that they actually did not reply on time. Only after the paper was done. And
so
this is one of the reasons.
And Concatenate is classical. I mean, that's, I don't know. You don't need anything special. Concatenate? Rings any bell?
No, so I only try to use datasets that are available, and
yes,
also.
But Concatenate is available. It's very, very classical. So have a look. I have an article in 2015 on databases and also on this classical things. So before the CNN, this revolution that took place. But one more thing. So maybe on the next, in the next article, you will take into consideration some other databases. But there is one more detail that I would like to know about. There are some special features in these databases. For instance, ISPA and also EffectNet, they are with spontaneous affective states. Is there any measure, any difference that you've noticed while working with them, comparing that with the one you obtained with the ones that are not spontaneous, that like acted?
So you mean if I compare other videos like from DISPA and
yes,
from
pictures
webcam?
and, yeah.
Yes, it was a bit different depending on how I was showing emotions, for example, on the webcam. Because, so for example, on the DISPA, the movement is a bit slow. And since it is not staged, and for example, the conventional only taking into account only 2 consecutive frames. This means that let's just say that the actor holds that special feeling for more than 4 frames, then it will be marked as neutral because they did not change. But in the case that I was changing like suddenly and not as fast, such that the intensity is still low, I saw a bit different in regards to the detection.
Yes, one more question, one more comment actually about that is that when you have, even if it's a short recording, even if it's an actor, then you have an apex of the effective state. And if you could miss that, that's one point, and well, that's, as you know, quite complicated. So it was just a brief comment. Maybe it's easier to compare with databases that are not that diverse in that sense, or to take into consideration something in particular that you want to prove. Because taking all in one place, that could give you some difficulties, some problems as well. Okay. I think that's all from my side. But, I think it's interesting, and we can maybe continue the talk afterwards. So, thank you.
Let's thank the speaker for her presentation. We invite Andrea and Andrea.
Hello.
Andrea is here. LFP microscopic analysis. Okay, we'll go to the next paper then. Andrea also, classifying test cases using neural networks. Andrea Neakshu is representing Babes-Bolyai University.
About my paper with the subject of classifying test cases using a neural network model. I wrote this paper together with my coordinator Vesca and Andrea. So during this presentation I would like to touch upon the aim of the paper, and I would like to further move on with the methodology and the process we used for defining our classification model. Then I will provide a brief state of the experiments we used, we ran, and also the solutions we obtained from running the experiments. And finally, I will conclude the paper. First of all, to talk about the aim of the paper, I would like to give you a little bit of context about regression testing, which is a methodology used basically for testing new changes in the software systems. It is a method known to be very practical, but it has some limitations like a lot of human effort and resource consumption. So to this end, test case prioritization is a method used for assigning an order to the test cases, such that those that are more likely to detect of faults in the system are run before the others. To this end, the paper first states an evaluation of the current related work in the area of test case prioritization. Then we propose a neural network classification model, and using this model we perform some experiments using history execution of the test cases. Moving on to the methodology, what we did was to obtain a data set which we pre-processed, taking into account mostly the verdict of the tests, which could be either pass or failed, 0 or 1. And there were a total of 325 cycles of regression, of the regression in which the test cases were run. Then we defined our models. We wanted to take into account several configurations for the models, and for this we thought of defining either 1, 2, or 3 hidden layers, each having 10 neurons, and we also combined this configuration with different optimizers, LBFGS, SGD, and ADAM. Then we trained our model and obtained the classification. So the process we followed has several steps. First of all, we defined our features. So in the initial data set that we obtained, there was just the name, the duration, and there were two other columns, the verdict of the test case and the cycle in which it was run. So what we did was to process that data set and obtain something similar to what I'm showing here in this table. We wanted to add a new column for every cycle in which the test case was run, and for example, for the first cycle, we computed the sum of how many times the test was run and the sum of the verdicts in that cycle. So this is for the features, and then the last two columns show the sum of all the cycle verdicts and the number of cycles that were run, that the test was run. Then, after having the features, we felt the need to normalize the duration in order to minimize the values of the labels without manipulating the difference in the range. And for this normalization of the duration, we use this formula. So the new duration will be the difference between the actual duration and the minimum duration of all test cases, divided by the maximum duration, the difference between the maximum duration and the minimum duration of the test cases. Then, having this normalization of the duration, we defined our labels. We obtained the labels in the range 0 and 150. So having the labels, we wanted to assign the classes, and we wanted to obtain a balanced data set. So we split this in three, let's say, equal classes. So in the range 0, 4, for the labels, we assigned the 0 less critical priority. Then in the range 5, 11, medium criticality, and then the most critical test cases were in the range 12 to 150. So a little bit about the data set. We used an industrial data set from ABB Robotics Norway. It is used for testing industrial complex robots. It had 89 test cases, which were run during 325 cycles, and they predicted over 25,000 verdicts. So a little bit about the configuration. As I presented in the methodology part, we wanted to have several configurations that we can compare and see which one would perform best. So we combined the optimizers, LBFGS, SGD, and ADAM with the three types of layers. One layer with one hidden layer with 10 neurons, two hidden layers each having 10 neurons, and three hidden layers with 10 neurons each. So having these 9 models, we compare them based on the metrics accuracy, precision, recall, and area under the curve. Moving on to the experiments, we split our data set into 80% training data and 20% testing data. And here you can see in this table the data that we gathered after the testing part. So we can observe that by far our best configuration is using an LBFGS solver with one hidden layer having 10 neurons. You can see that all the metrics are overpassing the range of 90%, but mostly we look at accuracy. Then, if we want to speak about the other two solvers with their configuration, we can see that SGD best performs when having 3 hidden layers with 10 neurons each. What we did further on was to define 6 permutations of the data set, of the test cases. such that we wanted to define two new metrics and apply them on these permutations and compare the results. But this is future work that we want to implement. I will just touch upon the permutations and how we obtain them, but there are no results for this part. So we took in the initial order here, you can see that these are the IDs of the test cases in their order from the data set. Then we applied a random function on the initial order and obtained this permutation, the random permutation. Then for the greedy permutation, we applied an algorithm considering the all cycles verdict. So those having the cycles verdict sum greater are at the beginning of the set. And then we took the three configurations that best performed in the experimental part and obtained three new permutations that you can see here. Okay, so for the conclusions, what we treated in this paper was the test case prioritization problem, that we wanted to come with solutions for it, and we defined our three classes for classification, for prioritizing the test cases, and defined different neural networks configurations for prioritizing. The results of the experiments showed that there was one that outperformed the others. And for the future work, we would like to continue the experiments by defining the two new metrics for the 6 permutations defined. One metric will be stating if the test case can find multiple faults in the system, and another metric will show how soon will the test run in the regression cycle. Thank you. This is all.
Thank you for your presentation. Questions, please? You perform various experiments there, you tune some hyperparameter of the system, but you show only the training and the test sets. Did you skip the validation set, or did you split the training set in some validation test also?
I skipped from the presentation, but I did some validation. I split the data set into training and testing, and I did the validation, then I ran them.
Have you tried also another solution, so not just splitting in 80-20?
No, it was the only configuration that we tried, but we can take into account for future work maybe.
Why did you need that permutation of the training set?
This is for future work. We wanted to define the two new metrics and to define the two new metrics that I was talking about, and then compare them based on these permutations. So it's, I think, something separate from the experiment that I performed. It's some new idea.
Other questions, please? If not, let's send the speaker. The next presenter, Lazar Camelia, about a paper about violence detection. Using what else than machine learning based method.
What we have actually tried, the results we obtained, and also the comparison with what is also in the literature. And finally, we'll discuss a little bit about the conclusions of the future work. So violence is one of the most serious crimes against society. This is present all around us. We can find this on streets, prisons, elderly houses, basically everywhere. One individual's animosity, concerns, as well as their economic and social backgrounds, might be the primary reason for the rise in the number of violent cases in the last years.
I'm sorry to not see. So the streaming is not working as it should. Here it's okay, but just wait a second because you have to fix it. Sorry for
Okay, we should remember if that helps.
No, no worries, but we have to stream it. Just a second, we can fix this.
Features cât și pe cele temporale, pentru că am folosit un LSD.
So, 3 minutes ago, please.
Okay, great. So, as we said, we can find this all around us. So, as a measure of precaution, a lot of surveillance cameras have been installed in almost all public spaces. However, this measure has more impact on discouraging people of having such behavior in public, but they cannot signal when such an act is happening anyways. And by creating a system which is able to distinguish in real-time violent behavior from non-violent one would be a huge step in terms of security for everyone. Okay, so in previous studies, the detection of violence was generally tied with the recognition of specific indicators, such as guns or blood, but also together with specific sounds like breaking sounds, screams, gunshots, and so on. So, however, surveillance cameras, which is the primary point of observation when we're talking about violence outdoors, does not usually record sounds, and this is why solution based actually on video content became a point of interest. Multiple approaches were proposed for identifying different types of violence, a couple of them being 3D CNNs, convolutional neural networks, support vector machines, random forest, and so on. I will briefly present now the methodology for this paper. So there are multiple reasons, actually, why violence detection in videos is highly complicated. To begin with, there is no visual description on what we actually define as violence. We can look at this as a gunfight, a fist fight, or any other type of conflict. And what all of these have in common is actually the idea of hurting another person. And an artificial neural network cannot comprehend this in the same manner that people do. And secondly, most of the time, even for a human brain, you need at least a couple of seconds before perceiving something as a violent action or not. And also you need a stream of data, not only just one image. This is why we also need to take into consideration not only what is happening now, but also what happened. So basically also the spatial and the temporal characteristics. Okay, so the approach described in this paper actually takes all of these factors into account. Due to the complexity of the problem and due to the limitation in size and variety of the data set, a complex model is required, and this is why, in order to obtain that, the transfer learning was introduced. Basically what we're doing, we are taking multiple deep models which are pre-trained on the ImageNet database and use them as feature extractors. In the second part of our proposed approach, what actually we're doing, we also want to take into consideration the frames as series. So we are using an LSTM-based neural network, which is going, of course, contain an LSTM set. And finally, for the binary classification, we are using a support vector machine classifier. Okay, during this study, transfer learning technique was leveraged using 5 pre-trained models. We can see them here: VGG16, VGG19, ResNet 50, Mobile and Net v2, and finally Inception v3. The model architecture at a very high level can be seen in the following slides. So first, we use the transfer values obtained from eliminating the first layer in the pre-trained model. Actually, why we're doing that, the last layer usually is the classification layer. We do not really need that. We just need the transfer values. Actually, for the second part of the model, we created a neural network containing the following layers. So first, we have an LSTM layer of 512. Then we have a dense layer with a size of 1024, which has ReLU as activation function. Then we have a dropout layer with a dropout rate of 0.1. We continue with a dense layer with a size of 50 having ReLU as activation function. And then a dense layer with a size of 2, which uses linear as activation function. And also we have here, very important, a kernel regularizer, which uses an L2 regularizer penalty of 0.02. And finally, our SVMS classifier. So why actually we chose these? So we need to keep track, as we previously mentioned, not only on what is happening now, but also what happened before. And this is why our LSTM style was added. Actually, LSTM from long-term memory is an enhanced version of recurrent neural network, very popular for time series analysis, which is handling the problem of vanishing gradient. Also, multiple dense layers were used for the custom network. We have chose these because they are going to interpret the spatial features we have previously extracted using the pre-trained models. And finally, LVM was chosen as classifier due to its capacity of finding complex relations between our input data without requiring complex transformations. The process of classifying videos as violent or not violent is split into parts. We can see them split at the middle. So in the first part, we actually have the first 3 steps. What's happening for each video in the dataset? We extract 20 frames. And these are going to be ingested by our pre-trained model, and the feature extractor from those features are extracted from those and then stored in cache files. The second part, which can be run independently, and actually this is what we did, is actually takes as input data, our hybrid model takes as input data what we have extracted previously, and we store it in files, and then uses the classifier for binary classification. Why we have done this is that we can actually stop in the middle. When we have a lot of data, we do not want maybe to wait for everything to run at the same time, so we can just first extract the features and we can use them for various models we want to use them. Okay, so let's take a look at the experiments now. First, I will present the data sets we used. So actually, the idea that I wanted to introduce in this paper was to actually combine all the data sets we have. Because what's happening, there are 5 publicly available data sets, but they only have like 1,000, 2,000 images, videos. So individually they are very small, but if we combine them, we can get the model to generalize better. So what data set we have is the AWF 2000, which is one of the biggest ones, contains 1,000 videos, and these are videos from real-life surveillance footage. Then we have the real-time violence detection. This dataset contains actually videos from YouTube. Then we have the hockey fights, which contains 1,000 videos from ice hockey matches. We have then the violent flows, which as the first one contains video footage, but also from crowd violence. And finally, we have our movie fights, which contains 200 videos from action movies. An initial Perfect. So an initial configuration was tested, which did not contain actually our SVM, the dropout layer, and the other layers were modified. And these are actually the results we obtained, which are not quite good compared to the literature. They are inferior to what has been happened before. This is why what we wanted to do, instead of using 80% training, 10% validation, 10% testing. What happened in this model and in this initial experiment, we changed using a 5-fold cross validation, and also we added the droplet layer for the overfitting part, because we also observed a couple of a huge difference between the testing and the training. Okay, so actually, this is the accuracy we obtained on all datasets combined using 5-fold cross validation, and this is the result obtained using inception retrieve as a feature extractor. And the highest accuracy we have for each of the 5. We compared for each of the dataset what was the best accuracy we obtained. You can see that all the models obtained the best accuracy on the movies dataset. But I want to mention here that I did not include the second dataset, the real life footage dataset, because all models obtained a 100% accuracy. Okay, but what we can see here that we have like very close values, but actually if we look in the tables I have in the paper, we can see that MobileNet V2 and Inception V3 obtained very good results on all the datasets, but the other 3 actually obtained a very poor result on the others. So comparing the results we obtained in our study to the results obtained in the literature, we can see that our proposed network performed better than state-of-the-art models on 2 of the 3 datasets. And the best result is obtained using Inception as feature extractor. So during this study, we found that deep learning is a possible solution for creating a model which is able to detect in real time the violence, which contributes, of course, to a safer environment for everyone. The objective of this work was to propose a hybrid artificial intelligence-based model, which is able to verify if a video content contains violence, which a video content contains violence or not. And to the best of our knowledge, this paper introduced two new things in the literature. The first one, as I mentioned before, was to combine all datasets and use all of those for testing and for comparing the results. And the second one would be the actual configuration, because to the best of our knowledge, it was not used before a pre-trained model as feature extractor, and an STM-based neural network, and then as SVMS classifier before. So that would be, and for the future work, we actually have a couple of those. First, I would like to highlight a limitation, and this is regarding the data set. Even though we have now 5,000 videos, they are pretty similar, and we will need, for better results, we will need a much larger data set, so we can compare what we have obtained on those. For example, in real life, we do not see the same violence as we see in movies or in hockey matches, so those data sets are pretty big, but not quite relevant to the problem we are facing actually in real life. Okay, secondly, when pre-processing the videos, instead of using 20 frames as we are using now, I would like to use the frame difference between 2 consecutive frames. Also, in the next studies, we would like to explore convolutional STM layers instead of the classical STM, because we might not need to use the pre-trained model for feature extractor, as the convolutional STM layers can do both of these tasks for us. Okay, and we also have a data set for our classroom classification. Actually, this is the idea where I started from with this project. I wanted to create a system which is able to detect violence in the classrooms, but the issue with that was that there is no data set available anywhere. I tried to create one on my own. It was quite difficult, so that's why I dropped it, because you cannot actually find on YouTube a lot of videos. They're mostly banned, which contains violence. So yeah, if we could get a data set for that, I think it would be a great step for everyone and for kids. And yeah,
thank you for your presentation. We have a short time for questions, please.
All right, let's try to see. So first of all, I understand that it's only presence or the absence of violence in a certain scene.
Exactly.
How, maybe I didn't pay enough attention at the beginning. How did you define this violence in your case? I think it's an important question, and looking at the very good results, it's natural that I'm trying to understand as good as possible. What's your definition of violence?
Yes, so actually I think the definition was a bit customized on what data I had to work on. So to explain a bit why I obtained such good results, I think it's mostly because what we currently have and we can currently work on is data which is pretty similar. So if my algorithm was in the training phase exposed to a lot of video content which is similar to what we have in the evaluation phase, I think that can actually explain why we have such good results, and this is why in the future work we have this idea of creating a better data set.
Can you see any nuances in violence, like for instance approaching something to showing some kind of violent signs, physical violence? Can you see some other kind of categories in that? Have you seen any paper?
The type of sign. I'm sorry, I didn't understand it. Do you refer if
the nuances of it, like
the nuances, the different types, different kinds?
Yes.
Yes. So actually, the violent flows data set, it's actually created for the crowd violence. So that is one of the most difficult ones to actually detect. It would be that. It would be the bullying which we have between kids, and this is why actually we need a separate data set for the classroom, because we cannot see like gun violence or in the school. Yeah, between kids I'm talking about. Yeah, unfortunately. So that would be like the bullying, the fist fights, the interactions, like violent interactions, which does not actually contain a lot of physical interaction. Like, I think also there we could add the sound. So because a lot of the violent interaction is actually made through words. But yeah, it was not the focus of my papers. Multiple which are not covered.
Are there, from your side, ethical concerns about working with this kind of content, reporting, developing the database? So what's your position on ethical aspects of this work?
So my position in terms of ethics, yeah, I think due to the fact that I did not create the data sets I've been working on, I cannot guarantee if they were not biased when created, because we do not know what type of persons are in the videos, if it's a specified race there multiple times with violent behavior. This is not something I can actually, in this case, I could actually control, only to remove those parts. But I think it's very tricky, especially nowadays, all of these parts to actually be, yeah.
And that's also correlated to the context, and that can lead to a more technical question. As you've already mentioned, some kind of violence can occur in a crowd or something. Is it possible, or do you have in mind to take at some point at least a part of the context in consideration in your work?
I didn't hear the last part, sorry.
Yes, so I said if you are willing or thinking of taking into consideration context in your work.
Yeah, I think that would be great.
And if you can elaborate.
Yes, so actually I think it's pretty important also, like where it's happening. As I specified in my paper, when we're actually like detecting something, it is very easy because we cannot always like see that this is a make in all context, but it's very hard when two people are actually fighting or hugging. Like this is very hard to detect, and I think the context also it's very important if this is happening, I don't know, under a bridge, or if this is happening in on the street, or this is happening in a nice restaurant. Like, what are the people doing? Like, if they came together, just all of these factors should be taken into account.
Can you focus on what you are planning to do with the kids? So what's happening in a classroom that is a kind of protected area from a certain well-defined context? What kind of, technically speaking, what kind of elements could you take into consideration in order to improve your, I mean, it's already high, but in terms of values.
Extend, yeah.
Yes.
Actually, I think for the kids specifically, usually bullying can be seen when there's a group of kids and the other kid is alone. Or I think that's, in terms of people, that's the basic one I can give right now. So it can be seen that when there are multiple people who want to hurt, they are usually more because they need courage from one another, and the victim usually is alone. And yeah, I cannot go into specifics on the psychology there because I don't know.
Thank you for your presentation. The next paper.
Thank you. So the next paper is Laura Paula, developing a virtual shopping assistant using automatic web crawling techniques.
Sorry, I'm having a probleme tehnice. Bine, tehnice în sensul în care trebuie să dau acces la film și nu vedeam de unde e, că mi se pare că am dat. Și nu mă lasă să dau share la... Deci... Da, dar mă gândesc că ar trebui. Ok.
Everyone, please take vă rog să luați apă sau cafea până începe prezentarea.
Cred că ok. Hello. To give you a little bit of context about this project and my motivation, in the actual context of this year, according to Global Digital Media Report, which is a report conducted by Global Web Index organization, in Romania, in the last year, approximately 16 million of users are users of internet. From these numbers, approximately over 13 of them are users of social environments, social media environments. Well, given these numbers, the group ages that are using these environments start from 0 to 4 years old and go all over to maybe 60 plus years old. Given all this information, it is pretty clearly, at least to me, that not everyone has such a nice experience when it comes to the need of purchasing new electronic devices. Why is that? Because electronic devices, in the moment of purchasing, you have to have a clear need, demands, and what you want from them. And not everyone has a strong technical background to be able to identify those features. So the scope of this project goes in the next way. This is aimed to those users who are users of social media environments and probably need a phone or a tablet or a laptop or maybe a smartwatch and so on, some electronic device, to be able to access that information. In this way, this project is aimed to those people with a lesser bag of technical background that wish to search and purchase a new device. So, the applicability of this system is meant to have a significant impact on a user's experience in searching these items on online e-commerce platforms. How do I want to improve this experience? By taking care of time management and decision making in the segment of users. As I said, the goal is for a regular user with a lesser bag of technical knowledges to be safe from both getting lost in numerous websites and from trying to understand an item's qualities, technical qualities. This being said, I have to ask myself two questions. Okay, how do I gather all this data that I can use to describe all these items, devices, and how do I filter this data, how do I process it, to be able to give recommendations to users? So, the first question is because the internet is considered to be a treasure of information if we manage to utilize it at its best. And because information is power, this study focuses on content-based filtering in recommender systems based on e-commerce data gathered through online scraping techniques. A little bit about data scraping. Data scraping is a technique in which information is scratched from unstructured or semi-structured logs, as in web pages, and is organized using automated software or a web bot. Web pages that we see every time we go on an online platform are constructed using text-based markup languages such as XML or HTML, and due to the dynamic nature of the internet, several data structures are utilized to transport data in the scraping process, starting from web pages and until we get it to our software. Because I'm talking about collecting online data, the platforms that I took into consideration for scraping are e-commerce platforms such as Emag, Altex, PC Garage, and Flanco. And electronic devices that also I took into consideration are phones, tablets, laptops, smartwatches, and TVs. These categories of products, from what my considerations, are used by pretty much everyone in accessing the internet and social media environments. When talking about web scraping, there is maybe sometimes a confusion created. Okay, are we talking about web scraping, web crawling, data processing? What is it and how does it work? In a process of web scraping, we can talk about two major components, a web crawler and a data extractor. So about these two components, first one, the web crawler. In general, the term of crawler refers to the program's ability to go over web pages, and most of the time maybe without a clear goal in mind, but by continually investigating a website and what it has to offer. What does that actually mean? A web crawler starts from a known set of URLs and goes over the web page in the scope of trying to find new URLs and continue on them and so on to gather all the data from those pages. Web data extraction, the other significant process or component, refers to the process of extracting data from web pages that are, as I said, in an unstructured or semi-structured format. So after extracting the data and manipulating, we can store it and centralize it in a database for a subsequent usage for many reasons. There are some key questions that come in hand when talking about creating a scraper project. Okay, what approach should I use when I try to build a web scraper? There are several methods, such as starting from maybe libraries, frameworks, desktop applications, and so on. From my perspective and how I'm seeing things and how it was the best fit for me, I investigated and I came to the conclusion that by combining two libraries, one for sending requests to a website to retrieve data, and one for parsing the data using an HTML parser, I came to the conclusion that I can maximize these utilities and gather useful information. So I'm combining request libraries with beautiful libraries, both offered by Python.
Because you have 2 more minutes for your presentation, eager to see your virtual shopping tool.
So, I'll go a little bit about, sorry for the delay. I'll go a little bit over the application architecture. So as I said, my application is based on scraping techniques and content-based filtering techniques. So we can see that starting from a known set of URLs, which are starting points for pages as TVs, laptops, phones, etc., we can program a scheduler in the background of our application and trigger through it some jobs, some tasks. This task, what actually does for each scraping process, we can trigger it at a programmed hour interval. So every day, a scraping process is starting. After gathering all data from the web content, data is sent over to a parser, and after manipulating into JSON documents and so on, and filtering and pre-processing, we store it in a database. Once we have the data stored, from the user interface, if a user try to send a request for gathering similar devices with his search, through the filtering component, these items are then displayed. So just a little bit more to give you a little bit of the flow of what is happening. We are starting from a document object model of a web page. So we can see we have a lot of imbricated levels for paragraphs, lists, tables, and so on. Data is then collected from all these tags and manipulated into a JSON object. After these processes that are taking place every day in an automated way, in the moment that a user makes a request to the database, what is happening? We gather all the data from the database and we first map it into a data frame. Why are we doing that? Because for each sentences, we want to map each word on a column in a row. Why we want to do that? Because to compute the similarity between 2 strings, we want to vectorize these sentences. And how are we doing that? We are computing some weights for each word in each sentence based on the appearance in each sentence and the overall documents. So after computing those, we have for each sentence and for each word from that specific sentence some weights. We can then vectorize each sentence and calculate the similarity between these vectorized sentences. These sentences basically are computing by joining technical specification for a specific product. So after computing these similarity metrics, we can then extract the most similar products with our search. So we order them in the same way. And after extracting this data and deciding what is the best fit for our search, we can after standardize our data to send it into the user interface and display it as it is. And that's it.
Okay, thank you very much. We have 4 minutes for questions, please. Do you explain the user why the recommended device is close to his search?
Yes, so if a user accesses this system, some indications are made in a way that products are recommended to him only based by his search.
So kind of why is this recommended to me? Answering this question, why this product is recommended to me?
Yes, so there is a section that explains that based on a user search and what specifications is he looking for, we recommend similar products with those specifications.
And you recommend only the first one?
No, I recommend, well,
All of
not all of them, but let's say the first 30, 40, 50.
Okay, thank you.
So your solution is based on web, and you've mentioned at some point that smartwatches could also be used. What do you think are the technical difficulties in doing that, or what kind of adaptations should be done in order to have a recommendation on a smartwatch?
What kind of specifications to be taken into consideration?
Okay. And are there any specific inputs? Are there constraints regarding the way that, so in this example we can see that you have a smart TV there.
Yes. So for every category of products, there are two ways of searching a product, let's say, to receive recommendations. First, by computing a non-technical form. What does that mean? A user has access to a non-technical form, and these questions are made in such a way that, let's say, a user is asked, okay, how much time you want your smartwatch to last? Maybe 3 hours, 4 hours, half a day, and based on these answers, non-technical answers are then mapped in the backend of the applications to technical specifications that are spread from the website. This is the first way to go, but the second way to go, if you just want to enter a link, I decided what specifications to take into considerations. So for a smartwatch, it may be the screen size, let's say, the brand, model, maybe the bracelet material, if it has GPS, what kind of other applications it has. And if you enter a link, I will do a match based on all those specifications that I took into considerations. But based on a formula, I will make the match only by your answers. Maybe a user is interested only in sensors that a smartwatch will ask for. So, and for each category is different.
Okay, let's send the speaker for our presentation. We invite Diana Murginean with a study on programming comprehension in embedded systems. So you have 10 minutes for presentations and 5 minutes for questions, please.
Poți să oprești share-ul? Assim. Hi, my name is Diana, and today I'd like to talk about our paper named Empirical Study on Program Comprehension in Embedded Systems. So today I'll go through introduction, investigative problems, objectives, methodology, experiments and correctness, results and conclusions. So first of all, the first question which arises, what is program comprehension? So I think everybody knows program comprehension is a large domain from computer science where its main concern is how developers understand and maintain the code. And since nowadays the amount of code has grown significantly, we must write very comprehensive code. Okay, so as Robert Martin says, the ratio of time spent between reading and writing is over 10 to 1, and we are consistent in reading all code as part of the effort to write the code. So going further, the investigative problems by us are very relevant to the context of program comprehension. First of all, we analyze naming concerns and code arrangement. When talking about naming concerns, we focused especially on single letter namings, on irrelevant namings, and on unpronounceable namings, as we see in the first image. And when we are talking about code arrangement, we focused on readability, on how code is formed. So the objectives that we proposed were divided into two groups. The first group focused on the findings, analyzed the findings made by our participants, which were findings relevant for the name of the variables, findings for the correctness of the answers, and measuring the performance. And the second group focuses on creating different comparisons between two variables, such as analysis between the names of functions and variables, as well as the arrangement, analysis the difficulty of performing the task, and analysis of the task correctness. So for the methodology, we used 66 participants for the study, which were mainly developers with different experience. So we have junior developers, middle developers, senior developers, so on. And also we had 3 students which participated to the study. The requirements to participate was to know at least one programming language and to know English, because the study was made in English. For the code snippets part, since the code snippets are everywhere, we have a lot of code snippets around us, they had to be relevant to the subject, so they had to include single letter naming, unpronounceable namings, relevant namings, and so on. They had to be written in C language and to be extracted for embedded systems, and also, as a result, we found 4 snippets. 2 were used as datasets in other research papers. One of them was extracted from GitHub, and one of them was extracted from Relate, which is a website from where programmers add code snippets from embedded systems. So the questionnaire design, each participant of the study was asked to complete a survey which consisted of 3 parts. The first part was regarding personal data such as age, years of experience, seniority levels. The second part focused on gathering opinion regarding general aspects of program comprehension, such as questions like how do you think using single variable namings would affect the code, and they had to rate the questions from 1 to 5. And the last part was grouped in 4 other parts, which was represented for each of the snippet. And we had similar questions to make a comparison between the 4 snippets. So the experiment task and correctness, we had 3 types of questions. I'm talking about the third part, where we had the code snippet. So we had open questions where we asked the subjects to give a relevant naming for some variables and some function names. Then we have closed questions where we rated how difficult it was to respond to the code snippets, and the third one was alternative questions where we outlined the motives why the code was not comprehended. And also here we added the possibility, so there was a list of motives that we give them, and also they had the opportunity to add another reasons for that. So for measuring the correctness, we created a key for each snippet, and then after we accepted the results, we applied the key to see if they answer correctly. So for example, for snippet 3, if a subject decided to add digit and check with hex, then the answer would be marked as correct. If not, the answer would be marked as incorrect. So as a result, the first thing we did was comparing the results from snippet 3, because there we had the data set. There we had a data set that was extracted from another research paper, and we saw that even that the other research paper had 300 participants, the number of incorrect answers from our study and from their study was similar. And also we noticed that the snippet difficulty between the studies was much harder for our participants than their participants. And for the snippet results, the first picture illustrates how much the percentage of people who responded with the appropriate naming for the open questions, and unfortunately only for none of the snippets half of the participants responded with a good naming. The majority of them, over 71%, responded that having a better naming for the functions, for the variables, would improve the code comprehension. When we did the study about the motives for not comprehending, the most important thing that the users noticed is that they didn't comprehend because of the single letter variable and function namings, and the impact for the comprehension, the variable that has the highest impact was the function name, because the subjects of the study responded that the function name would indicate the scope of the function, and without having a scope of the function, that they didn't know what to expect the function to do. So as conclusion, the problem investigated by us is very relevant in the context of program comprehension. We included naming concerns and code arrangement concerns. The methodology, for the methodology, we have 66 participants which have to respond to answers given for the 4 code snippets that we choose. And as a result, I have to say that namings just have relevant and very important so it's very important for code comprehension. Yes.
Thank you for your presentation. There's time for questions, please. Invite the audience for questions. How do you plan to use these empirical results, for instance, to develop some technical instrumentation?
So for future work, we would like to propose this, to give this study, this survey to people who work every day with C language, because the analysis we did on snippet 3, the subjects for the other research paper were only people who work on C language. So that's why we think that the results from our paper were so low.
Mm-hmm.
And we want to make a difference to see if that was the problem of our paper.
Where did you find 66 people? Is it a kind of collaboration with some company, or?
Well, I work and I asked my colleagues from work, and everybody was so angry because I gave them C# snippet. And also I asked my colleagues from the university.
Thank you for your answers.
Is there anything specific to embedded? Like, have you tried for some specific embedded? It's in general.
In general, no. I don't.
And you've mentioned C. I suppose you are working in a company, people are using C kind of embedded devices.
No, they are not. No, they are not. That's why I think the answers were not so great for the code snippet.
And what would you expect to happen if you are doing that?
Well, the code snippets that we choose were not so hard to comprehend from my point of view. So I thought that if you know a little bit of programming language, that's why we require it, the results would be much better. But it didn't turn out
since
that
you
way.
mentioned in the title, then I asked you about that.
Yes, but the code snippets were part of larger classes that we extracted from embedded system classes.
Thank you again for your presentation. We invite Roxana Bagiut with a paper related to sentiment analysis on short text. And this one. Bagiut Roxana is here. Okay, please. paper is on Romanian language, yes? Ok, până se pregătește Ioana, I will invite the next speaker, Boa Rurado.
Today I'm going to present to you an architecture for inspecting Bluetooth traffic and software-defined networks.
Good.
To start, I'm going to tell you what's a software-defined network. So, in a traditional network, the hardware usually does two things. It serves also as a data forwarding domain, and it also controls the packet forwarding based on some rules. In a software-defined network, these two planes are decoupled. So there is a plane, the data plane, which only acts as a medium for transportation of the packets, and there is the control plane, which provides policies and rules for those forwardings. This control plane is logically centralized, but physically decentralized, so there can be many more applications which have a global overview on the network. I've chosen to apply this paradigm on a Bluetooth network because Bluetooth is now a protocol that nowadays is found in almost every device, and we use it kind of unconsciously. And because it's so widely used, it's also prone to a lot of security breaches. So, software-defined networking enhances the way in which you control the network, and this could apply very well on a Bluetooth network because it has some limitations due to its way of being built. The security issues of a Bluetooth network have to be monitored very carefully, but this thing cannot be done by a human agent very often, so we have to find a way to make it more automated, and that's why software-defined networking helps us, because we provide policies for which, by which the traffic is filtered, and we find several security issues by filtering the traffic automatically. My solution to this problem proposes 3 applications residing in both the data plane and the control plane of SDN architecture. In the data plane, we have an antenna, Ubertooth 1, which is the wireless development platform, which enables us to monitor the traffic in an area. This data, selected from Ubertooth, is then collected by an application, which converts it to a custom format, which we've created especially for the communication between these 3 applications, and then forwards these packets, the custom payload, to the processor application. Next, we have the main controller, which allows parameterization for 2 types of anomalies that we are trying to detect. So first of all, we are trying to detect MAC spoofing attacks, which are a kind of attacks that mean that an attacker assumes another's device identity and performs malicious, sends malicious data into the network. And then we detect also brute force attacks, which mean that by executing a brute force attack on a certain network or a certain Bluetooth device, you find its Bluetooth address, its MAC address, and then you can execute all sorts of other attacks on that device. We have the third component, which is the processor, which applies the policies parameterized from the controller and applies them on the data that has been forwarded from the collector application. To customize the traffic inside our SDN network, we created a custom protocol for us to have the minimum possible data lengths that our application could work with according to our specification. So we created a protocol which uses exactly the required information, and these packets, which are 4 types of packets which flow from one application to the other, are constructed with only the required data. To simulate and see if the architecture is working fine, I created some attacks. So I saw online how to do some attacks. I had some Bluetooth devices on which I performed those attacks, and in the meantime, while those attacks were performed, I recorded the traffic using Bluetooth, and then the output I've provided as input for my architecture, for my applications. First of all, I used a traffic analyzing program to see if my protocol works fine. So here I chose a random packet, which corresponds to a controller processor package. So in here we can see that we sent a brute force attack policy with a parameter 51. That means that 51 is the minimum number of packets that the packet frequency which is recorded as being a brute force attack. And finally, because we were talking in the context of security, it's very important that any attack should be discovered as soon as possible. So a malicious intent does not execute for too long, so it could damage our data or our infrastructure. We divided the processor application into 3 parts. So it was the networking phase, which meant the transportation of information from one application to the other, so serialization and deserialization of data according to the protocol. Then we had the data structures and building phase, which meant building in the processor application the required data structures that our detection algorithm works with, and the actual detection phase, which meant applying the policies from that were defined in the controller and apply them to our actual data in those data structures. First of all, we applied only one policy, so we tried only detecting the MAC spoofing attack, and then we tried to apply the both, and we can see the results here. And as expected, one policy always takes a little bit shorter than 2 policies, because on the 2 policies part we have a little more information to process, and we have to perform a few more extra checks than on the 1 policy. But on average, the detection takes less than 1 millisecond. This part is the last one is theoretically the most important here. And as a conclusion, security is a very important issue overall in networking, but in Bluetooth, because we use it so much every day, I personally, when I first started to study this topic, I didn't quite think of the implication that the performed attacks on the Bluetooth network would have, and it's very important to detect those as soon as possible, because any problem which appears can cause a lot of damage, like I don't know, turning off a device or recording sensitive data, which can then be used in other malicious purposes. And also the software-defined network allows us to fully parameterize everything and control the network as smooth as possible, and provide every application with the required data as soon as possible. So identify the breaches and perform the checks which have to be performed to identify those attacks. And that's pretty much
Thank you for your presentations. We are following for questions, please. Used two policies.
Yes.
In practice, how many policies are used to protect again in the context of Bluetooth security?
Well, there are, in a paper that I've read, there were at least 20 different policies that could be applied to detect some issues in the Bluetooth network. But because we had the hardware limitation, so the Bluetooth device could only record the signal strength that is being received from a device, and we could also track the packet frequency, so how many packets we receive from Bluetooth. So by having only these two metrics, we could only detect much fewer attacks. So we came to those two. But in practice, there are more than 20 possible issues with the Bluetooth network.
Thank you.
Well, a brief question regards, you said at some point that you use some Bluetooth devices. Can you be more specific? What kind of Bluetooth devices can you use?
I used a Bluetooth speaker, Mi Band 5, which is a fitness band, and 3 phones, two Samsungs, and an iPhone to track my
as it seems, from the OSI perspective, you are low level. What about the services? Can that influence in some way the services offered by Bluetooth? The kind of attack you are getting, have you thought about it?
Well, here the SDN plane applies on the application layer. So we work on the low level, but the services don't influence us very much in this context, because we do not require information about what services are performed, but we check here only how the packets that perform those services are transmitted. So the actual service does not matter in this case.
Well, let's consider maybe a case of a Bluetooth device that's always on. For instance, like advertising a certain area or something, or information. Okay.
As a beacon.
A beacon, yes. I was thinking about it. Thank you for the beacon. Exactly. That's, I think, more vulnerable to this kind of attacks, isn't it? And if yes, then the software-defined trivial solution. What should take into consideration, or your solution is? get more specific to your case?
Well, first of all, beacons have a special type of communication. So, as being a device that only transmits information, you cannot directly connect to it. And you cannot perform the same attacks as you would perform on a device that is connectable or discoverable and connectable. So this type of communication is a little bit more special. So it's not prone to as many errors or security breaches as would a regular device that you can connect to. That's the first point. And in the second point, my architecture has a big downside because we can only monitor. For now, we can only monitor the data. So we can check only if an attack was performed, but we cannot interact and react to that particular attack. So we can only keep track of the device and of the attacks. And as a future work and a future improvement would be to also react to this. And to help this, so now we're using one Ubertooth device, which can track only one, which can only monitor the data. But if we had another Ubertooth, we could also react and start sending packets to counterattack that attacker.
Okay, thank you for your presentation.
Thank you.
Roxana, please. The next paper is about sentiment analysis on short text, platform in the Romanian language.
Hello, my name is Ioana, and I will talk about sentiment analysis on short text, the case of the Romanian language. So this is the content. We'll start by defining sentiment analysis. Okay, so sentiment analysis is the identification of the sentiment behind the given instance. So basically, it analyzes people's opinions, feelings, and emotions towards something like service, product, organization, etc. And in this paper, we'll discuss the sentiment analysis of reviews. This type of research has an endless uses. Okay, it can be used in business analysis, in social media monitoring, in brand reputation monitoring, voice of the consumer listening, etc. Okay, so we have two goals. We first want to construct a good accuracy classifier that will automatically classify a given review. And we want to evaluate the maturity of existing language resources for the Romanian in order to see if they help us in the classifying process or not. So this is the workflow we follow. First of all, we use the biggest e-commerce platform in order to scrape the reviews. Then the raw scrape data is pre-processed. The whole process is in the orange section. So we first remove the missing data if there is any. Then we balance the data. Then we lowercase it and make some removals. We remove the HTML tags, punctuation, numbers, diacritics, and extra letters from words. Then we remove the stop words since they don't help us. And lastly, we normalize the words using stemming. And so at the end of this process, we should have only the clean and balanced data. Okay, so the next step, which is probably the most important one, is the feature extraction, where we transform the words into numbers. Here we use three techniques. We try classical bag of words, TF-DF. Then we try two-word embeddings, word-to-vec and fast-track. And lastly, we try Romanian pre-trained model distillable. After this, we do a bunch of experiments. We try different machine learning and deep learning models and evaluated them. And depending on the results of the accuracy values on the validation data, we try to tune them in order to get the best classifier. And at the end, we draw some conclusions. Okay, so data gathering. The data set was extracted in January this year by web scraping, and it contains reviews provided by IMAG buyers when they purchase it phones. Okay, so in order to understand this process, it is important to know that the reviews are dynamically loaded in each product's page. So we use the Scrapy framework in order to go through all of this product page and extract the information needed to construct the URLs from where we can access all of the reviews for each product. And these URLs were saved in a JSON file. Then we used request library in order to access each URL from the JSON file. To access this information and extract information about product name, score, title, and body of the review. Okay, so we managed to extract 41,928 reviews. You can take a look at the extracted data set. Okay, each review has one rating from 1 to 5. And because we only interested in the body and the score, we dropped the rest of the columns. Now, before moving on, if you look at the distribution of the ratings, you see that the data set is highly unbalanced. So we can't actually work with this. So we first need to balance the data into three classes, negative, neutral, and positive. Now, if you look at the left graph, you see that most of the reviews have a score of 5. Then there is this score of 4, and the rest of them 1, 2, and 3. So we can assume that the users perceive the 5 score as the positive one, the 4 score as the neutral one, and the rest of them as the negative one. After balancing the data, we have 60,125 reviews, each of them in a class of those negative, neutral, and positive. Next, the text cleaning process. Here's an example. You can see in the table how the original text changes from across each step. Okay, so from the original text we lowercase the tags, the punctuation, stop words, number, diacritics, and extra letters. Then we normalize the text using stemming. So this process of text cleaning is very customizable. We only use the steps we need. For example, in this case, we skip the diacritics removal and stemming in the distilled case. Before moving to the feature extraction, we split the data in 80% training, 20 testing, and we use 50% from the training as validation data. Now, the feature extraction method, so as I said, we use the classical bag of words, the TF-DEF, which uses the frequency of the words. Then we use two models for the word embeddings, word2vec, which was trained on the original set, the one with the 41,000 data. Then we tried the pre-trained fast text model in the Romanian language, and lastly we tried the distilled. Okay, here are the combinations we tried so far. For the TF-DEF, we tried the Bernoulli based model, then random forest, support vector machine, and simple deep neural network. For the word embeddings, for the word2vec and fast text, we try recurrent neural models, LSTM and GLO. Then CNN. For the CNN, we tried 1D CONNET. And lastly, we combined the distilled with a simple deep neural network. Okay, so the experiments part. Here are the validation accuracy for the combination of TF and DNN experiments. We tried two optimizers, MS-Pro and Adam, and from the results you can see that the model worked better with the Adam optimizer. It showed better accuracy values. Now here are the test results for the machine learning methods and the deep learning method using TF. And you can see that the best result so far was the support vector machine, followed by the deep neural network and the random forest, which had very, very close values. Next, for the word2vec and fast text, we use the MS-Pro optimizer. Here are the results for the validation accuracy. You can see that the word2vec worked better for each experiment conducted, while the fast text only managed to get 70% accuracy for two combinations. For the gated recurrent unit experiments, again it worked much better using the model trained on the original data. And the CNN model, the CONVNet 1D models, work worst, okay. Now here are the results for the word embeddings models combinations. You can see that the gated recurrent unit worked best for both cases. Now for the distilled bird, we tried the three combinations so far with different learning rates and epochs. And from the performance graph, you can see that it still stays underfit. It doesn't reach overfitting. Also, the accuracy on the test for the last experiment got only 67% accuracy. Okay, here's an overview of the results conducted. So again, you can see that the super vector machine and the gate recurrent unit using the word-to-vec model had the same results on the test set, while the Distilbert model had the worst results. And yeah, random forest and deep neural networks had very similar results, as I said. And yeah, as a conclusion, we can tell that the pre-trained models did not help us as much as we hoped. But we can still experiment on them. We can try more combination. We can combine Distilbert with LSTM or Jerome to see what we get. Also, we can try some other pre-trained models like Robert or Borg, which is the parent of Distilbert, to see if we get better results.
Okay, let's thank you for this presentation. I have only 1 minute for questions. Please. Where does your system fail? Where does your system fail? For which kind of reviews?
Our system fails as in...
It does not manage to classify them correctly. Did you perform this kind of error analysis? For which kind of texts or reviews your system is not able to classify them correctly?
Well, it depends on the model we use. So, yeah, I didn't make some tables.
To look at the text to see, okay, look at this kind of text, my system is not able to figure out the correct sentiment. Okay, thank you. Maybe my colleague has another question.
Should I ask you, maybe, as you did not mention too much about future developments, what would you like to do, the next steps? You mentioned something, but if you can develop it.
As I said, I would like to try the Robert model and the BERT model, which is much bigger, has a bigger capacity. And I would like to combine them with some other type of neural networks, such as LSTM and GERU. And also I read some papers where they combine TF weighting with word-to-vec. They got some nice results. I'd like to try this as well.
Thank you.
Let's thank the speaker. And we invite Oksana Kisturian. Also it's sentiment analysis and it's some empathic chatbots.
I'm Oksana Kisturian, and I will be talking about the application of sentiment analysis in psychotherapy using conversational agents. The agenda of what I'm going to talk today, I will start with the problem statement. I will provide more details about the conducted systematic literature review. Then I will present perform experiments that conclude with a proposed model, and this model is integrated in the application, and I will provide a very short application demo just to see how I implemented this. Starting with the problem statement, I chose to propose a multidisciplinary approach that combines sentiment analysis, conversational agents, and some psychotherapy techniques. I chose to do this because nowadays people feel a large range of emotions and they are quite difficult to control and can have negative impact on people's lives and can lead to stress and depression, which are serious issues. And for this reason, I try to propose something that can help the user to guide him through emotional management. The adopted methodology was a systematic literature review, which consists of 4 main steps. First, we define the research questions, and those research questions are like, which are the possible approaches on sentiment analysis, or can conversational agents be used in psychotherapy? Then we identify the studies using different databases like Google Scholar, IEE Explore, ResearchGate, and so on. Then we define selection criteria just to result in a final list of papers because in the beginning we had like 77 papers and we have to manage those and result in 24 papers. And then those papers are analyzed and their results will be presented in the following screens. From my point of view, the most relevant results consist in the approaches of sentiment analysis. As you can see in those graphics here, the machine learning approach is the one that is highly used. And for this reason, I chose to explore further the approaches on machine learning, which you can see in the right side of the slide. And other interesting results from this systematic literature review consist of the potential of conversational agents, and in a paper I discovered that some authors said that they may become a technology revolution, and of course more research is needed in this area. In order to determine the most performant model, I performed multiple experiments. And for this, I had to consider multiple recent datasets. Those datasets are Carrel, Go Emotions, and Mel. Those are based on Twitter, Reddit, or Friends TV show data. As you can see, each dataset has like 6 or 7 emotions. And for Go Emotions and Mel dataset, they're highly imbalanced. And I try to consider balance in the dataset, but this means that either we remove important data or we generate fictive data that can have a negative impact on our results. Now that we have the datasets, I tried to define multiple models, and I ended up with 5 model architectures. The first one is based on long short-term memory networks. The second one is a combination of long short-term memory networks with convolutional neural networks. The third one is the convolutional neural network model. And the fourth and the fifth one is a concatenation of those 2 models. And the difference between them is that the fourth is simpler than the fifth one that is more complex. As for the results of the experiments, you can see here, maybe it's not really clear, but in the right side we have model results for each data set, and I think it's better to look on the left side of the which represents a graphical representation of the results for each model on every dataset. You can see that the model performed best on Carrel dataset, which they had like similar accuracies over 90%, and for Go Emotions and Mel dataset, the results were not quite satisfactory, but it was kind of expected because, as I presented earlier, the datasets are highly imbalanced. So, for this reason, the proposed sentiment analysis approach that is used is considering the second model with the correct dataset, which had an accuracy of 95%. You can see here the training results on the right part of the slide. And moving forward to the application of this sentiment analysis model that we determined before, I tried to use it integrated in a web application that combines also psychotherapy concepts. And I'd like to present you some concepts that are used in the application. I use cognitive behavioral therapy, which is based on what you think and what you do affects the way you feel. And I try to implement some things in the application through conversation, breathing technique, journaling, and fact check. But I will show you in a minute. So, because we don't have a lot of time, I'd like to... We have? Oh. I try to actually present a scenario, and I already did it like a half hour ago. If you see, I'll start by saying hi to the chatbot. Then the chatbot says, "Okay, it's great to see you," and ask how have you been. Now I say that I'm feeling down. Well, oh, sorry, I didn't mention. I was thinking of being scenario-based testing, and I'm a first-year student, which I failed an exam, I feel awful, I feel like I'm no good at anything, nothing goes wrong, nothing goes right, and this is the case, so I'm feeling down, that's the feeling. The sentiment analysis model analyzes this sentence, like I'm feeling down, and identifies that I'm sad. So then the chatbot would reply to, asking me if I want to provide more details about how I'm feeling. Yeah, sure, why not? Is it a specific situation or a core belief? Is it a core belief because I feel it's like a general thinking, I'm no good at anything. It's not about the exam, it's like I feel like I'm no good at anything at all. And this is a technique that is used in psychotherapy. You have to write down your thoughts, like I feel I'm no good at anything. Then provide evidence that this thought is a true fact or it's not actually. Like I feel like I'm no good at anything because I failed my exam, but now. If I think further, for a reason that is not a true fact, this thought of mine, is because, I have good grades at other subjects, and maybe if I study more, I can pass the exam next time. So now that I provided those responses, I can analyze that. Actually, I'm no good at anything, but because I failed my exam. But actually, I have good grades at other subjects, and I can do it next time when I will pass. So, in the end, the user should feel better because he analyzes how he feels, and now he should feel better. Another interesting feature of the application is the breathing technique, which helps the user to calm his body. Here is a short animation that I try to design to be really helpful for the user. You have to breathe in for 4 seconds, hold the air for 4 seconds, breathe out, and hold again. And this breathing technique is called square breathing. And another feature of the application is the journaling technique. You can add notes here, and the sentiment analysis model will analyze how you feel. And I just created the account, so I don't have data here, but I will try to log in with another account that I've been using for a while now. just to see the analytics part, which I believe is really interesting. You can see the emotions for a period of 1 week, 2 weeks, or the last month from conversation or from journaling, if you select here. So this is the results from the last month for only data from journaling. I believe it's quite interesting to see how you manage to feel in this period of time, just to define some patterns of how you feel. So this is what I wanted to present about the application. And for conclusions, I believe that the overall objectives of this paper were achieved, but I believe there is a lot of research needed in a lot of areas because I used different areas. I believe it's required to research more on sentiment analysis, on psychotherapy techniques that can be implemented in this application, and on conversational agents too.
Good.
Thank you.
For your nice presentation. 2 minutes for questions, please. How good is your chatbot? Do you perform some evaluation metrics against your chatbot?
No, unfortunately, I didn't have time to perform some evaluation metrics.
And the second question?
Second question. In one sentence, what would be your original contribution?
There are a lot of original, only one.
One statement. one thing that you are proud of.
I believe the integration of the sentiment analysis, because usually we just analyze from a computer science point of view, like we determine which is the best model, and we determine it, but how should we apply it, or where, and I believe like the whole application of the sentiment analysis in this area would be the original application. Contribution.
Great, let's thank the speaker. We invite Andrea with a paper about bug reports, priority, accuracy, machine learning. Precipitarea de premiere se încearcă a fi la ora 2. În sala 19 este lângă Someș și colegii din spate să vă ducă pe cei care nu știți. Și Andreea ne va ajuta să ajungem la răzări acolo.
Okay, so my research paper is about bug reports priority classification model. And the problem here is that the bug tracking system receives a large number of bugs daily, and the bug tracking is very time consuming because now it is done in a manual manner. And we propose an approach to automatize this bug tracking in order to improve the software system quality. And I will start with some related concepts like what is a bug. A bug is an error, a malfunction, a program that produces unwanted or incorrect results in a software program. And the important thing here is that each bug has a priority label, which is marked from P1 to 5. And P1 means that this is a very high bug, a blocker, and needs to be done immediately. And 5 priority means that it is maybe one fix or it will be fixed in some years. So in order to maintain a good software product, you have to do this bug tracking process in a correct manner and assign the right priority. Okay, so like I said before, how to determine the correct priority label. in this approach, we aim to automatically prioritize this bug report. So, in order to retrieve the priority, we performed an analysis on the textual description of each bug report, because we believe that each description of the bug report can contain important data on its prioritization. And we started with a systematic literature review. I won't talk more about this, but this helped us to see the relevant researches that has been done before on this subject. Okay, so we start with the data set. We performed an analysis now on 2 data sets. We extracted both of the data sets from the Bugzilla bug tracking system, and we only extracted the summary and the priority of each bug report. We extracted one data set that contains, for the project Eclipse, the GDT project bugs, and we extracted another one that contains only database management system bugs, and we extracted that by performing a search for words like database and SQL. And here we can see a snippet of the bugs that we extracted. Here I am talking about the text processing model. So we extracted the bug reports, we performed text pre-processing, we split the text into training data and test data, and we applied a CNN-based classifier. Okay, here I'm talking about how we applied the classifier. We applied 3 layers, and first we started with the embedding layer, which we constructed using the word2vector, and for using CNN we used the Keras library from Python. And as evaluation metrics, we performed the evaluation on test data having 50% of the whole data set and 25%, and as we can see, that 25% is better at the results. And we also compared the results that we had for the GDT dataset and database related dataset. Of course, for the GDT dataset we had better results, but this is because the GDT dataset is bigger. It has 1,200 bug reports, and the database related one has only 1,000. Okay, and we also performed an evaluation with other results that we previously implemented for the same GDT dataset that we use here. Before we applied the naive Bayes model and linear regression model. I did that on my license thesis, and now I compared the results with the CNN Bayes model. Okay, and we performed an evaluation by priority distribution. Well, by applying precision recall F measure, we obtained much lower results, but this is mainly because of the priority distribution level. We believe that by having a data set that has many P3 priority bugs, it is not that relevant. We should expand our data set to have more of the 1, 2, 4, 5 priority levels, to have them like equally distributed. Okay, and as a conclusion, we perform a bug priority automatization method, and we believe that by further processing and future work, we could implement this solution to help the software developers on bug triaging and maintain good software quality products. And we had good evaluation metrics, because by performing the SLR, we can see that we have similar results with other known results in the industry for this field of priority classification of bugs. Okay, so as a future work, of course, we want to expand our data set, of course. We are thinking about at least 10,000 bug reports for various projects, and of course that have the priority label equally distributed. And that's all, thank you.
Thank you for your presentation. We have time for questions, please. Input is text.
Yes, input is text is the summary of the bug report that we extracted from Bugzilla.
And you perform experiments with CNN and a couple of years ago with other techniques.
Yes, with linear regression and naive Bayes.
And is it better CNN than the other ones?
Well, I think that I think we can obtain better results with CNN than with linear regression and naive Bayes, but we need to run a few more experiments maybe add one more layer or add another articulation function to some of the layers to obtain better results.
Now the tendency is to diet, for diet. So instead of increasing the data or the neural network, you need to simplify it.
We also think that maybe in this study data set, maybe there are some duplicates, like maybe there is the same bug report that is expressed otherwise. So maybe also performing a text pre-processing and removing the duplicates would help the algorithm.
Thank you.
Other questions? Okay, thank you.
Then let's send the speaker. Răzvan Gabriel Dumitrius și sau Sebastian Antonio Toma. Something about statistics.
Yes, I think I will share the screen from my phone if it's okay. Wait,
Please.
It works.
It works. Prime decomposition, mathematics, statistics.
Yes, kind of.
Smart screen or what
No, I just try to share my screen from my phone too, because I have my presentation on the phone.
On the phone? Works?
Yeah, it should work.
Android, iPhone?
Android. Doesn't work.
Any messages, concerns? May I help you with something?
Yeah.
Do you have experience with this kind of phone? No.
Okay.
Yes. First one. You may start.
Okay. So hello, my name is Sebastian Antonio Toma. I'm together with my colleague, which is absent today, Răzvan Gabriel Dumitru. We are presenting a paper on computing the Fisher's test using prime decomposition. So today I will show you the usage of our project, the related work in the area, which is kind of non-existent, our idea, and some results and conclusions. So the usage, we use our project to compute a more efficient way for finding the Fisher's test. Fisher's test, more exactly Fisher's exact test, is a statistical test using to determine the non-randomness between two categorical variables. And usually to better display it, I showed you an example of a 2x2 contingency table of the Fisher's test. So just some values. And the general formula for this kind of 2x2 contingency table is this, where n is the sum of a, b, c, and d, and a, b, c, and d are the values in the 2x2 contingency table in this one. So in this case, a is 1, b is 9, c is 11, and d is 3. And as you can see, the formula is like very complicated and computationally inefficient for big values of a, b, c, and d. And it takes a lot, even good computers to compute. So related work, we didn't find anything related to this We just had from our teacher, previous colleague of us that implemented the Fisher's test very efficiently in Java. And also we tried to do the Fisher's test with the fraction library from Haskell, to compete with our results, because we implemented a new library called pfraction to better compute the Fisher's test, which passed both of these ones. Okay, so our idea of the library, we wanted to represent factorials as prime numbers. In the pfraction library, we represent everything as prime numbers, like we have a number in an integer or a floating number, and we represent it as its prime decomposition, as the numerator and the denominator. And we also use it for factorials. So yeah, the division and multiplication and addition and subtraction, everything is done more efficiently. It's just basic operation on list, and the list is composed of a pair of the prime number and its exponent, and then in the end we just have to do subtraction and addition. So it works well on very large numbers, because we don't store the number, we just store its prime decomposition. And for the factorials, we decompose it the same in a list of prime numbers, but we don't decompose it we don't compute first the factorial and then decompose it as a normal number, because this would also be inefficient, because of the purpose of our paper is to not compute the factorial, because it's the one that is computationally ineffective. So here we describe what we observed, how to decompose a factorial in its prime decomposition more efficiently without computing the factorial. And for that, I give you a basic example. So we have the number 10 factorial, and we want to find the factor of the prime number 2 in 10 factorial. By this, we divide 10 by 2, we get 5. So that means 2 appears at least 5 times in 10 factorial. So the factor of 2 in 10 factorial is at least 5. Then we increase the power of 2. 2 squared, which is 4. 10 divided by 4 is 2. Yeah, like integer division. So that means that 2 appears at least 5 plus 2 is 7 times in 10 factorial. Then we increase the power again, and we obtain 8. 10 divided by 8 is 1. So 2 appears at least another time in the decomposition of 10 factorial. And then if we increase the power again, it will be 2 at 4, which means 16. 10 divided by 16 is 0. So yeah, it appears none of them. So in the end, 2 appears 5 plus 2 plus 1 times. So the factor of 2 in 10 factorial is 8. So 2 at power 8. So, and if we compute 10 factorial and we decompose it, we see that the prime number 2 is the power of 8, the decomposition of 10 factorial. And so on, we go to the next prime number, which will be 3, and so on, until we decompose the factorial without computing it. This is the general formula we obtain. So the prime factor x, actually the prime number p will appear x times in n factorial. And this is way more efficient than computing the factorial, because we just use n, not n factorial. In our implementation. Okay, to assess the results, we computed the Fisher instead of A, B, C, D, we put everything into A and subtract 3, and the rest we put it once just to be more efficient, because we perform some simplifications and using the following factorial just to have as less factorial as possible. Here you can see the chart of our final. So on the y-axis we have the time in seconds, and on the x-axis we have the power of 10 of our data set. So we see that for 10 at 7 is still very efficient, but yeah, for 10 at 8 it takes a lot, it's like 15 minutes or something, but it's still way better than the other implementation. So using the Haskell fraction library, only got to 16 seconds, but ours did 0.18 seconds. And like as you can see from the table, our implementation is the only one that reached the final number, where the sum of the ABCD of the values is at the 10 power of 8 or something. And for the rest of the implementation that we found, it took a lot of time. I mean, it didn't come to infinity because we waited like almost an hour and still they haven't finished. But our implementation got only 15 minutes for the last one. And as you can see, it's way faster even for the smallest one. And that's all.
Okay, great, thank you.
Thank you.
Questions here? I found your approach very original. I didn't know that computing Fisher test is so challenging. Do you have a mathematical demonstration of your observations there? So starting with the original formula, but you need some
of the prime decomposition of a factorial.
Yes.
I don't think we have like. I mean, it's if you think about it, it's kind of a bit logical. We don't really have a demonstration, but we can work on that.
We need to prove that. Okay, thank you. If there are no further questions, let's thank the speaker. And we invite Camelia Petrina for presenting a software defect prediction model, a replication study, but still original, somehow.
Hope so. Hello, my name is Nadezhda Camelia Petrina, and today I'm presenting you a software defect prediction application study. The agenda for today is the problem statement, the methodology, the prediction models, results and conclusions. Why isn't it showing? Oh, okay. The problem statement, as we know, the software defect prediction has become quite widespread in the recent years because it takes a lot of time and resources, and as you know, sometimes they are limited. The machine learning prediction models are applied for reducing the time and effort for both the tester and the programmers during the development stage. The motivation of the article is that we want to facilitate and observe the testing programs to reduce the time and effort for the testers and programmers. And the purpose of the research is to compare the results that we have by applying the three models, machine learning models, with the results from the research paper that we replicate. As I said before, this is a replication study, and I'll show the research paper that we replicate and the bibliography. There are 4 dimensions of the replication study. Operationalization here is similar with the original study because we use the similar machine learning models, and we use the same data sets. Population here they are the three machine learning
algorithm, naive Bayes, decision tree, and random forest. The protocol, those three algorithms were applied on both entire data sets and the data sets after applying the hybrid feature selection method. And the researchers here are different from the original study that we replicate. The methodology. There are three different data sets used. All of them are from the NASA MDP repository, and those are as follows: PC2, PC3, and PC4. NASA MDP repository is that database that stores problems, products, and data sets. In our data sets we have, in the first one, PC2, we have 37 columns. In the second one, PC3, we have 38 columns. And in the third one, PC4, we have also 38 columns. Because we want to facilitate and to observe which are the best features for our datasets, we made the heat maps for all of the datasets. Here we can see the correlation matrix of the PC2 dataset. Here is for the PC3 dataset. And here is for the third dataset, PC4. Data preprocessing. As I said before, the attributes of the datasets are for the NASA MDP repository, and they all are in the RF format. And we investigated them with Weka Explorer. We eliminated the missing values from the datasets, and we used the hybrid feature selection for to extract the good features for the datasets. And here we have the NASA datasets before and after applying the hybrid feature selection. After applying the hybrid feature selection for the PC2 dataset, we had 5 columns. For the PC3, we had 7 columns. And for the PC4, we have 4 columns. Prediction models. As I said before, in this study we applied 3 different machine learning models: naive Bayes, decision tree, and random forest. And for the evaluation metrics, we chose 2 of them: accuracy and metric correlation coefficient. And here in the image we have the implementation of MCC evaluation metrics. We just applied the formula of the MCC. The selected models, as I said, they were applied to both the entire datasets and the resulting hybrid feature selection datasets. And the technology and function used, where we imported all the algorithms from the Learn library from Google Collaboratory. Fit function was for our data training, and predict function where we perform the classification on the test vector matrix given by the input variable. And the results, here we have 2 tables. Okay. We can observe the accuracy table based on the models. Here is our results. In the first table is our results before and after applying the hybrid feature selection method. The results of this replication remains consistent with the original study, and the conclusion we can see based on the 2 tables are that the naive Bayes model has the highest accuracy for PC2, that is 95.53 after applying the hybrid feature selection. The decision tree model has the highest accuracy for PC2 dataset, also for the PC2, which is 0.30. After applying the highest after applying the hybrid feature selection, and the random forest model had the highest accuracy for PC2 dataset before the HFS method, which was 98.66. And for naive-based model, the conclusion based on the second table. Here we have the second table. The naive-based method has the highest accuracy for PC2 after applying the HFS model. The decision tree has the highest, and the MCC was highest for PC4 after applying the HFS method. The decision tree has the highest accuracy for PC2 and before and after applying the HFS method. And MCC is for PC4 with 0.46, and the random forest has the highest accuracy and MCC for PC2 with 98.9, and for PC4 with after HFS with 0.50. This is what I talked about. And the conclusion, as we talked, there are the problems of the problem statement of the software defect prediction. That is a replication study of the article I'll show you in the next slide. The datasets used with and without hybrid feature selection. Results of the study, we observed that random forest has the highest values for both MCC and accuracy. And feature work, on the feature work, I'd like to include more datasets from the NASA MVP repository, and to apply more machine learning algorithms.
Great, thank you for the presentation. Questions if you have? You predicted 95% accuracy. How many bugs are in a software, or where is the bug in the software?
Not where is the bug. How predictable is the program to have a bug in
every program?
Yes.
Has bugs.
Yes.
So from this point of view, we can predict everyone here that
that some program have or not a bug or not.
Have you tried with some boosting solution, like for instance AdaBoost?
In this research paper that I found and read that I replicate, yes, they applied the AdaBoosting, yes.
Okay, thank you again for your presentation. And next, Victoria will present something related to augmented reality. Please.
Good afternoon, everyone. Hopefully, the pictures.
text.
Yes. Good afternoon, everyone. My name is Victoria, and today we're going to talk about augmented reality. So, within the context of quick development of technological solutions in the 21st century, the subject of augmented reality became very popular and a widespread area of interest. So, what is augmented reality? Augmented reality represents an interactive experience of a real-world environment where the objects that reside in the real world are enhanced by computer-generated perceptual information. As for now, augmented reality is called a better version of our reality. In the latest years, augmented reality has been employed in different application areas, and among them, e-shops give their customers the opportunity to check their appearance, makeup, hairstyle, hair color, and clothes, and even shoes. In this paper, a system that allows online jewelry shops to provide a way that customers can virtually try on items is presented. The major challenge of virtual try-on apps development is the way in which the product is presented to the user, and more specifically, real-time or deferred solution. In the case of the virtual jewelry, the real-time solution is preferred, since the user can move, rotate, and interact with the system. Regarding the size, a dynamic size would be preferred so that the user can check how different sizes of the items fit his or her hand. And also the integration phase with an existing e-shops is another challenge. While all modern augmented reality SD keys provide solutions for 3D virtual objects, the online shops provide only the 2D images of the products instead of virtual 3D models. So our system overcomes these challenges by implementing the following features: downloading all products photos from the desired website, real-time coordinates adjustment for the user's fingers, finger selection, item zoom in, zoom out, and a comparison between the marker-based and the marker-less solution. Okay, so in order to give a little bit of context on augmented reality, some of the related words are presented. So first of all, augmented reality is classified in location-based, marker-based, and marker-less AI. Here we can see the feature, the newest feature of the Google Maps. This feature was implemented recently, and it aims to give more specific location information by augmenting user scene with the location pins and direction indicators. So in the location-based AR, the system takes the GPS parameters and the digital compass data as input and returns the augmented scene. In the marker-based approach, this system takes as an input camera stream, detects the markers, and displays 3D rendered virtual object. So here the authors present an AR system used for astronomy delivery lessons. Even if marker-based approach is often efficient and reliable, placing a marker in the workspace of the user can be visually intrusive. So, due to the recent development of AI and pattern recognition systems, the markerless AR has developed. And Handy AR, this is the system presented in this slide, is one of the first systems which demonstrates that markers can be easily replaced with the user hands. So this system takes camera stream as input. It doesn't have any markers, but even though it can detect the coordinates where the virtual object should be augmented. So this is the pipeline of our system. As we can see, we're taking the website and introducing it in our web scraping module. We're getting the virtual 2D object and performing some perspective transformation. And on the other hand, we're getting the camera image from the real world, introducing it in the media pipe solution module, and getting the fingers coordinates. Then we're making use of masks and bitwise operations in order to create the foreground plan, the background plan, and then overlay them in order to get our augmented scene. So prior to the process of augmentation, an algorithm which detects and tracks user's hand has to be developed. A pure image processing algorithm for hand detection and tracking was developed, but it turned out to depend too much on a clear background and a high visible contrast between user's hand and the background. So we had to come up with a solution which doesn't depend on the scene's background or illumination. And while coming natural to people, robust real-time hand perception is a very challenging computer vision task. And so we made use of the MediaPipe hand solution, which is a high-fidelity hand-finger tracking solution. It employs machine learning to infer these 21 3D landmarks. And even if these landmarks coordinates are very accurate, they require adjustments so that the coordinates fit the user's finger. And here's where our contribution comes. In our approach, the landmarks with the IDs 9, 10, 13, and 14 are identified and then adjusted. We identified 4 cases in which the adjustment should be done. So the first case, when the user's hand is in this vertical position, so we are getting these 4 coordinates and we have to translate these coordinates to the left so that it fits the ring's finger. Another position is when the user's hand is in a horizontal position. In this case, we have to perform the translation downside. And there are 2 more similar cases when the user's hand is in this and this position. Alright, and the augmentation process. The main idea of augmentation, as I mentioned, is to overlay the product picture over each camera frame. And the final augmented picture will consist of 2 overlaid plans, the background plan and the foreground plan. And in order to achieve this overlay effect, masks and bitwise operations were used. So to create a mask, we should follow the following steps. So first we have to load the ring image, we have to blacken the background, transform the image from RGB to grayscale, apply binarization, erosion, dilation, and blur effect in order to select only the important part of the ring. And once these steps will result into a mask, which basically represents a white image with black pixels, as shown in the last image. Once the mask is ready, a bitwise operation between this mask and our camera stream is performed. And this operation blackens our region of interest in the camera frames and gets us the background plan done. To get the foreground plan, the inverse of the mask is used, which can be obtained performing the image negative operation on the mask. And so we get the foreground plan. With both foreground and background plan, the augmentation is done by performing a bitwise OR operation. The marker-based approach differs slightly from the markerless method. While the augmentation algorithm is the same, the recognition and tracking part is one which differs. So this time the markers coordinates have to be identified and sent to the augmentation part. And we use the latest state-of-the-art arrow markers, which are presented right here. Here you can see the result of the marker-based approach. And the accuracy of our application was computed using the image mask from webcam, which was computed by applying a binarization on the camera input. So the mask camera was considered a ground truth image, which means a picture that can be considered true according to reality. Then the number of common black pixels between this camera mask and the ring masks for each frame was computed. And if the number of black pixels from the ring mask is equal to the number of common black pixels, that means that the frame accuracy is 100%. For each measurement, a dataset of 100 pictures or frames were taken from camera, and the system was tested for 6 different hand positions as stable position, slow hand movement, hand rotation, sharp movement, or slow hand movement plus rotation. The results are presented in this table, and the final accuracy of the markerless approach is 90% and only 80% for the marker-based approach. So 2 types of approaches have been implemented and compared, marker-based and markerless. The markerless development implies model recognition and additional coordinates adjustment. So from the development point of view, the markerless solution is harder. But from the user's perspective, the markerless approach is more convenient, as it's less intrusive and it doesn't require any special items like a crafted wedge. The stability of the markerless approach is relatively higher, while the marker-based method depends a lot on the quality of the markers and the maturity of the SDK used. And the external conditions dependency is more visible at the marker-based approach. And also the accuracy depends a lot on the scene illumination and occlusion in the case of the marker-based solution. So as from the user's perspective, stability and external condition dependency, markerless solution is our definite winner.
Great, thank you. Questions? Can you enumerate some elements of originality of your approach?
Yes, so the augmentation itself, so the bitwise operation, this was our approach. We wanted to use bitwise operations in order to make very fast system, and the coordinates adjustment were also our part.
Good, thank you. This concludes our session. Let's Sala 15, picul de